Well, good morning, everybody, and welcome to the University of Brighton. I'm Andrew Lloyd. I'm the interim Vice-Chancellor here, and it's a great privilege to welcome the bibliometric community to the university this morning. Before we start, as always, I've got a few housekeeping issues. There is no scheduled fire alarm, you'll be pleased to know today, so if the alarm does go off, that means that there is a fire. Can you please, if that's the case, just follow the green signs and exit the building, and the fire points are just outside for assembly. The toilets are located on the ground floor here. You can get to them out through these doors at the side, or you can get to them by going down the stairs at the top. So with that. So it's great to see so many of the bibliometric community here in Brighton or attending virtually. I don't know if any of you are Brighton graduates, but I'm sure many of you will be aware that Brighton did have for many years a well-recognised and respected Department of Library and Information Sciences. Over many years, like so many subject areas, we saw significant decline in interest, leading initially to closure of our undergraduate and then postgraduate position. However, I'm delighted to recognise that with the growth in the role of data science and analytics in society, we have naturally seen growth in these areas in universities. And I was reflecting last night how much bibliometrics has been at the forefront of these developments, evolving from our historical information sciences provision. Although now only a small component of huge data sets which we train our students to be able to understand, analyse and critique are those bibliometric data sets. But it is very much something which led to the evolution of data analytics and data sciences. Bibliometrics continues to have such an important role within universities, as highlighted by some of the keynote speakers today at this conference. Capturing the advancements in technology developments, such as those around artificial intelligence. Looking through the programme, I was really taken by the research community, which is not only looking at how AI can contribute to bibliometric analysis, but also to how bibliometric analysis can be used to address some of the challenges we are facing with the misuse of AI. I believe that this will be a fascinating conference, and as a scientist, I wish I had the time to come and listen to some of the fantastic presentations which form part of the event today, and look forward to what I see as an exciting and very much forward-looking programme. I hope you all have a great conference here in Brighton. Enjoy the hospitality of the university, but I also hope you have the time to explore our great city, everything that our diverse and vibrant community has to offer you. Enjoy your time with you. Thank you very much. And I will now hand over to Barbara.
Thank you too much for your kind words, Professor Andrew Lloyd. Dear colleagues, welcome to LIS-Bibliometrics Conference 2024. It's a great pleasure for me to see you all today in person and virtually. As mentioned before, we have not had the chance to meet in person since last March 2020 when we celebrated the conference at the University of Leeds, before the pandemic dramatically impacted all of us. So I'm glad that to see you all today, celebrating our conference once again. The conference theme this year is Exploring the Bibliometrics Universe. We cover current topics affecting bibliometry, such as research integrity, research culture, AI, new indicators. The conference is intended to be a diverse space in which everyone feels included. Nowadays, bibliometrics databases have become more sophisticated, more powerful, thanks with the implementation, for example, of AI and new open databases, with the implementation of open science initiatives, and also the reform of research assessment. So it's great to see how universities now fully utilize bibliometrics responsibly, creating a better culture for their staff. However, bibliometrics still grapples with some challenges, such as paper mills, hijack journals, predatory journals, questionable publishing, and nowadays we can buy citations and also authorships. So this is the context in which bibliometrics nowadays is operating. So, as a bibliometric practitioner and as scholars, we understand the significance of combining different databases to create a more comprehensive and diverse reports. So we make sure that we don't exclude scholars from different parts of the world. With sources such as Overton, nowadays we can track the citations to policy documents, which is fantastic. Thank you, Overton. In the UK, bibliometrics is still a very niche area, but thanks to our community of practitioners and scholars, bibliometrics is recognized at very high institutional level and greatly helps to institutions with horizon scanning, for example. I'm very optimistic about the future of bibliometrics in the UK and beyond. Bibliometrics is here to stay. The LIS-Bibliometrics Committee and I are aware of the challenges that the community is facing regarding training needs. So the committee is here to support the community. So for that, for us to better understand what are really the challenges that the community is facing, we have created a survey that we will greatly appreciate if you can complete it. We will launch, well, we will send the survey at the end of the conference. So we will appreciate your participation in providing us with your important input. Without further ado, enjoy the conference. We have a fantastic 3 keynote speakers, Professor Jennifer Byrne, Dr. Álvaro Cabezas, and Professor Caroline Wagner. Thank you, the 3 of you, for accepting the invitation to come today. We have a great variety of presentation and lightning talks from the community. And also, we come with the support of 5 great, wonderful sponsors. Thank you so much, Elsevier, Clarivate, OurResearch, IET, and Overton. Without your support, we couldn't be here. So thank you for making this happen. And at last but not least, thank you all of you for being here virtually and in person. Enjoy your conference, and I hope you have a great time. Thank you so much for coming to Brighton.
Hi, everybody. Without further ado, I'd like to introduce our first keynote speaker, Professor Jennifer Byrne. Jennifer joins us from the University of Sydney, where she's spent her scientific career analysing childhood and adult cancers at the molecular level. She is also leading the PRIMER group, which stands for Publication and Research Integrity in Medical Research. And today she's going to share with us her research into paper mills. To you, Jennifer.
Thank you very much. I might switch and use this microphone. Right, can people hear me? Is that working? Fantastic, all right. I'd like to thank the organisers very much for the invitation to come here today. So, yes, I will be talking about research paper mills in biomedicine, with an emphasis on the work that we've been conducting in this space for the last 7 or so years. How many people here have heard of paper mills? Would you mind raising your hands? Oh, well, that's a record, I have to say. I don't think I've ever spoken to an audience where so many people have said that they're aware of them. So I think that's going to make my job very, very easy. Yes, so I do lead a small research team. We call ourselves the Primer Group, and our work is supported by the National Health and Medical Research Council of Australia, which is, I suppose, the MRC equivalent here in the UK, and also by the University of Sydney. I'm going to provide a bit of introduction to research paper mills, even though many people here and possibly online are familiar with paper mills. I'll then give some background to our research and a brief overview of it. I am a cancer researcher. My background's molecular biology, so I will need to explain a few concepts, a few key concepts in that field, and I'm worried that I'm not going to do it very well, but bear with me. Then I'm going to talk a little bit about what we think we know about paper mills and finish with some of the big challenges as we see them and some possible solutions. So many of you probably will be familiar with this concept that research publications can be viewed and valued in different ways. Research and scholarship should be produced with the aim of benefiting society in some way. Of course, in a commercial publishing world, publications also have a monetary value, particularly to their publishers. And we cannot escape that publications also have career value, and that these values can be placed differently on publications in different settings and parts of the world. There is no problem here, though, as long as the societal value of publications is what trumps everything else. Publications need to have commercial or career value because of their research value. And if they don't, publications can be quickly reduced to commercial or career tokens. So paper mills, what are they? We've defined them as entities that sell undeclared publishing services. And I've added unethical to this list because by virtue of the failure to declare them, they are unethical, and they're unethical in many other ways. So what they produce, I mean, we really only know them from their products, or at least the products that we believe they produce. They are likely to produce some genuine, likely low value data sets or manuscripts, but we believe, at least in biomedicine, that the majority of their products are falsified or, more likely, entirely fabricated. So authors can purchase an entire manuscript, or they can purchase a position on that manuscript. The paper mill will also take care of manuscript submission, editorial handling through editors that they may have placed at the journal. They will take care of peer review if the journal will allow that. They will help with post-publication commentary if papers are brought to the attention of journals or the public. And we also believe that they forward sell possibly citations to their own work. So this might seem a bit surprising, but these kinds of advertisements are actually very easy to find. This one was found well over a year ago by my colleagues in the States, and you can see here that there are 3 papers for sale. The middle one, the first position, has probably been sold, but for the others there are a number of authorship positions that can be bought. And these kinds of advertisements are very, very easy to find. They're advertised on Telegram, they're advertised through Twitter and social media. So the ecosystem of paper mills largely comprises 4 main actors. So on the left, you will see the people who need to publish. Notice that I haven't referred to these people as academics or researchers because they are not, in all cases, these kinds of people. Sometimes they are people who are expected to publish despite not having the time, resources, or training to actually carry out this activity. So these people provide their identities to the mill and money, and the paper mill produces the product that's purchased, and then the manuscripts, sometimes the article processing charges, and the promise of future citations goes to the journals. You will see that I've listed these different actors as either being inside or outside. If they're inside, they know what they're doing. If they're on the outside, they don't. So for journals, we probably have some journals that are collaborating with paper mills and others that are being duped. Then the publications then benefit the institutions through publication metrics, through the possibility of future funding, and through the possibility of enhanced prestige. And then institutions help to turn this wheel by providing or imposing publication quotas on their staff and by offering career rewards for publications, which sometimes can be direct cash rewards. So it's really the money that turns this wheel. So what were some of the early signs of paper mills? Paper mills have probably been running for more than 20 years. But as organisations that operate under the radar, their activities only became apparent about 10 years ago. One of the early papers in this field was John Ioannidis, who described a geometric increase in the number of meta-analyses that were being published. So meta-analyses is a form of analysis of existing publications. While some of these might have been produced by individuals as a relatively quick form of producing a publication, it's likely that this is something that is industrialised by paper mills. Around in 2014, people became aware that there were some quite effective peer review rings operating, where papers were being reviewed by individuals who were, in some cases, the authors themselves, or possibly as well people that are working in association with the paper mill. Elizabeth Bick published a paper in 2016 where she found duplications of images in scientific publications in about 4% of the papers that she screened. And then in 2017, we published our first paper on this topic where we described very similar human gene research papers with implausible errors. So I will talk to you a little bit about our first paper and then the subsequent papers that we've published. So this was the first one. You can see that the title talks about striking similarities between publications from China, commonly describing a particular kind of laboratory experiment in human cancer cell lines. So I first discovered these kinds of papers just by reading papers that described a gene that I had identified about 17 years before. So the gene that I found was one of a family of genes, and I've worked on these genes for about 25 years. But this particular example I didn't think was particularly interesting. So I was quite confused when, over a short space of time, there were 5 very similar papers that all looked at the same gene. They all produced the same kind of results, but in different cancer types. So as an expert and as somebody who has done this kind of research, I felt it was very unlikely that anyone would be interested in that gene in these cancer types. I was also surprised by the similarity between some of the figures. So the papers contained very, very similar figures, despite being authored by different people. To me, as somebody who has supervised this kind of research, it looked to me as if it was the same person actually making these figures, because they were so similar. But we became more concerned when we checked the identity of the nucleotide sequences within these papers. So gene research requires the use of small pieces of DNA or RNA to interfere with the functions of genes. They are written according to the genetic code, and they have labels attached to them in the text. So this particular paper, you can see that there's 2 sequences I highlighted in dark yellow and their identifiers in light yellow. So the identifiers are different, but the problem here is that the sequence is the same. So you cannot do the same experiment and get very different results, as is shown in the right panel. So these nucleotide sequences in publications, we refer to them as being small but mighty. They seem very anonymous. They're just series of C, G, A, T with their descriptors, but we can decipher them very easily to work out what they really are. In this case, these sequences are supposed to be non-targeting controls. They should not show any genetic identity to a human gene. We can very easily show that they do. And that means that their use as negative or non-targeting controls is invalid, and that invalidates every result in these kinds of papers. So my colleague in France, Cyril Abbé, saw me basically fact-checking the identities of these sequences, and so he wrote a program called Seek and Blast to do this in a semi-automated way. We published this in 2019. We then published an openly accessible standard operating procedure explaining how to use the tool, and this is the new site where you can access Seek and Blast, and it's always been freely available to the community. We then applied Seek and Blast to screen just under 12,000 papers to look for these wrongly identified sequences. and verifying the identities of more than 13,000 sequences by hand, which was a terrific body of work conducted by Yasunori Park, we found over 700 papers that had at least one wrong sequence, typically more than one, including more than 10% of the original papers in one of the journals that we screened. So amongst other paper types, we screened the publications in two journals. One is called Gene and the other is Oncology Reports. So they're quite different journals. We chose them deliberately for this reason. Gene is a journal that has been, I think it started in 1979, and it publishes gene research across many different types of species. We were only looking at human research, but nonetheless, we found in 2017 and 2018, approximately 4% of papers with wrong sequences. In Oncology Reports, the situation was considerably more pronounced, in part because Oncology Reports is a human-focused cancer research journal. Nonetheless, it was very concerning to us that we had up to 12% of papers with wrong sequences in this journal. We then decided to look specifically at high impact factor cancer journals. Having looked at two journals with impact factors between 2 and 3, we chose two cancer journals. Again, they're actually published by the same publisher here. They're both Springer Nature journals. Oncogene is a very old and well-respected molecular cancer journal. It's had a very constant impact factor. Molecular Cancer is a more recent journal that's had a very striking increase in impact factor between about 2017 and 2021, sorry. So we screened all of the papers in molecular cancer in every second year by hand this time, and found that in 2020, at a time when its impact factor was 27.4, it had 38% of papers with these incorrect sequences. And screening a comparable cohort in Oncogene, we found 40% of papers with the same error type. We also found a new issue in these some of the more recent papers in these two journals. So for the first time, we found genetic targets that we could not verify. These were, in all cases, particular RNAs called circular RNAs. They're a relatively recent research topic in molecular biology. We found numerous examples of circular RNAs that were either so poorly described that we could not validate them, or circular RNAs that we believed probably did not exist. So this concept of non-verifiable reagents then informed our most recent paper, which we published in April this year, where we described non-verifiable and unknown cell lines in cancer research papers. So cell lines are basically the cells that you can grow in dishes in the laboratory. They're a very popular experimental model because they are quite inexpensive, easy to obtain. Generally, you don't need ethics approval to grow cell lines and study them, unlike, of course, doing research on small animals or on humans. And there are also many individual cell lines to model many diseases. But they do have weaknesses. They can be contaminated if they're not correctly grown. And they also have considerable naming or nomenclature problems. They are often given these very non-intuitive repetitive names that sometimes can be shared by other things, and they can be variably written and misspelled. So what we found, though, went beyond misspelling. So this is an example of a wanted poster that was made by one of our authors, where we found misspelled versions of cell line names that were claimed to be cell lines in their own right. This was very surprising. There are many opportunities to actually verify the identities of cell lines in publications. They should be indexed in the major cell line encyclopedia, Cellosaurus. Their establishment should be described in early publications. If an author says that they've obtained the cell line from a particular repository or supplier, then that cell line should actually be sold by that repository or supplier. And if authors claim that they have obtained genetic fingerprints of those cell lines, then those genetic fingerprints should be available somewhere online. Unfortunately, for the cell lines that we described, none of those things were true. So we found, by studying 420 papers, we found 23 non-verifiable human cell line identifiers. We studied 8 in detail, and of those 8, 7 were claimed to be independent cell lines, but we could not verify their existence. Most of those papers have again been published since about 2014, and these types of papers are still being published today. In our publication, we propose many actions that might reduce descriptions of non-verifiable cell lines. The one that I think we're most keen to pursue is establishing a dynamic register of these kind of misspelled cell line identifiers and non-verifiable cell lines. This is a difficult thing to do because most repositories or registries actually describe things that exist, and here we are describing a registry of things that don't exist, or at least that we believe do not exist. Nonetheless, I think this is very important to alert researchers to this kind of problem. So in terms of what we think, what we have proposed, in our first paper in 2017, we proposed that these very similar cancer papers that describe implausible errors could reflect a system of mass or industrial scale research fraud, claiming to examine human genes, largely in cancer cell line models, where contents might be created through templates, using a kind of a theme and variation approach. For speed and efficiency, and the rapid content generation might be associated with higher error rates. We also propose that there are intrinsically, we and others I should say, propose that there are probably two kinds of research. There's research that's relatively resistant to fraud because it's difficult to fabricate the data at scale. Research becomes very vulnerable when the ease at which work can be fabricated is much greater than that of genuine research. So we think that research becomes vulnerable to fraud when it's either difficult or expensive or slow. And in some cases, of course, research is all of those things. That is particularly the case for human gene research. So human gene research typically can take 5 to 10 years to publish work because of the requirement to obtain funding, regulatory approvals, purchase resources, hire staff, do experiments over years, and then you start writing. Unfortunately, the paper mills don't need to do any of those early things. They can start work on the manuscript immediately. So they have an enormous advantage over genuine research. We also think that gene research is attractive to this form of fabrication because it offers both scaling and dilution factors. There are many topics that can be exploited. For example, we all have 40,000 individual genes that can be studied in different biological or clinical contexts and using the repeated application of very well-recognized techniques. Many different kinds of authors can publish human gene research, different fields, institutions, and countries. There are many journals that cater to this kind of research. It can be published across massive interdisciplinary journals, for example, and this can all go on for a very long time if it's either not detected or we choose not to act. We believe that journal oversupply is also a factor that favours paper mills. Where journals are supported by article processing charges, this can favour a focus upon quantity over quality. Of course, it's relatively easy to create or grow online journals, but it is very difficult to scale and sustain quality operations through the reliance upon editors who are, of course, leaders in their field and therefore a finite resource, peer reviewers who are experts in their field, and quality manuscripts, which are difficult to produce when research is difficult, expensive, and slow. So this kind of research, such as gene research, simply cannot be scaled to meet some kind of fictitious demand that's created by having too many journals. So now I'm going to talk a little bit about the big challenges and some possible solutions. So this comes from a paper that we currently have under submission, or it's under review, talking about the kind of research that we need. A really big challenge is that we don't know very much about the paper mill problem at all. We need really to understand the features of paper mill products. We think we know some of them. We think that there are probably generic features that reflect the fact that they are being scaled, but obviously many features will differ depending upon whether papers are published in biology, chemistry, machine learning, It's also possible that these kinds of features can change over time, particularly, of course, in response to the use of generative AI, and I'll come back to that later in the talk. We really don't know the scale of the paper mill problem. There's been almost no research conducted or published to talk about this. And so, of course, unless we understand the scale, we cannot really make sensible recommendations or progress. We know very little about how the organisations themselves operate. There have been some publications published around 2013 and 2018. This kind of research is obviously difficult, but understanding the workforce that paper mills rely upon, the types of clients that they support, how they conceal themselves, how they collude with institutions, journals, publishers, would help tremendously. It would also help to predict the scale of the problem and possibly some of the features. We know very little about the awareness of paper mills. It's interesting that many people here are aware of them. Probably within publishers, many people are aware of paper mills. But within the research community, we believe that awareness still remains very low. So we need to understand who knows about paper mills and then design evidence-informed education programs so that people can at least be aware of the problem. And finally, probably the area that we know the least about is the impact of these papers. How are they cited? How is the information within these papers transmitted through the literature? What impact are these papers having upon researchers in fields that are being targeted? Are paper mills changing researchers' like research problem choices? Are they affecting people's careers? We have done a small study on that, which we're in the process of analysing and writing up, but we need much greater research and research conducted at scale. Possibly the second problem that I'd like to talk about is our experience of post-publication correction. So in our experience, this is simply not working. Every time we find papers with errors, we describe them to journals and publishers. We've published about our experiences, at least in some cases. So this paper that we published in 2021, we described the responses of journals and publishers to a set of papers that had the same nucleotide sequence error, so these non-targeting reagents that actually target human genes. We found that journals sometimes correct these papers, sometimes publish expressions of concern, sometimes retract, sometimes do nothing. I was a co-author of this commentary that appeared in Nature about a month ago, and within this commentary we included our experience of post-publication correction of the 712 papers that we described in 2022. So of that group of papers, at the time when the paper was published, we knew that about 4% had either been corrected or retracted. But then about 18 months after we had communicated those results to the publishers and the journals, only 5% of those papers, additional 5%, had actually been corrected, had an expression of concern or retracted. And I should say that most of these cases, from the notices, it seemed as if these notices had nothing to do with the information that we communicated about incorrect reagents. So if we look specifically at the responses by gene and oncology reports, they're very similar. 18 months later, 98% of papers remained uncorrected and 95% for oncology reports. So we have proposed possible solutions. In 2020, we had thought that perhaps an expressions of concern is a notice that's underutilised because of the term concern. We thought that perhaps publishing a more neutral notice might help, such as an editorial note. We had proposed that this could be restricted to the kinds of errors that we study, verifiable errors. It could be published quickly. It could be indexed. In 2021, we proposed an error notification template to allow researchers to describe to journals and publishers the kinds of errors that they're finding, which ultimately could be published. But now I don't really think that either of these kinds of approaches are going to work on their own. This is some unpublished data from two of my colleagues in the States, who believe that suspected paper mill products are rising exponentially, whereas the responses to these papers are not. So I think we actually need a broader range of ways to correct the literature. I think now, this is again another paper that's currently submitted. We believe that papers need to be able to be flagged by researchers independently of publishers and journals. One way that this could happen would be linking signed pub-peer notices describing, again, verifiable errors directly to papers. We've also proposed a possible reactivation of PubMed Commons, which was linked to PubMed, and this could be linked as well to PubPeer. We really need to raise researcher awareness of paper mills, because researchers can act immediately simply by not reading. And researchers, if there's one thing that researchers like doing, it's not reading papers, believe me. Perhaps the most disruptive possibility would be a system of journal accreditation. So ISO standards are widely used in laboratories and research infrastructure. We could create an ISO standard for journals, which would address minimal standards for both publication and correction. This would produce 2 journal tiers, accredited journals and non-accredited journals, but the recognition of accredited journals by funders and institutions, I believe, would be a game changer. So what actions can we all take? Well, we can all learn about paper mills, promote education and awareness in our communities. We've published a number of commentaries about paper mills, and they're all freely available, open access. We can also help others make better decisions about what they choose to read, what they cite, what they review in terms of manuscripts, where they publish. And we can advocate for scaled and immediate responses to paper mills and their publications. We are concerned that AI or generative AI could turbocharge paper mill capability, allowing them to reach new types of clients, spreading to different kinds of journal and research, and allowing them to exploit topics that might have previously been unavailable to them. Generative AI could also result in papers that are more plausible and sophisticated and that contain fewer or no of the errors that we currently study. However, as somebody that has been studying cancer for a long time, cancer is a really difficult thing to study because it has been with life on Earth for probably 1 billion years, evolving, learning, changing. Whereas we've only been publishing these kinds of papers for the last 20 or 30 years. So this is a problem that we've made, and I believe that we can fix it. I'd like to thank my team, my collaborators, thank our funding bodies, and I look forward to hearing your questions. Just before I finish, I'd also like to advertise, this is a little advertisement. I'm part of a team that is creating a new open new platform for meta-science preprints called MetaRaw. So if you're interested in preprints and meta-science, please look up MetaRaw and consider submitting to us. But thank you very much.
Is this working? Yeah. Thank you so much, Jenny. What an enormous challenge. Does anyone have any questions? Okay.
Thank you for the talk. Very informative indeed. Actually, I've got 2 questions. I don't know whether I should file both of them together. Okay. So my first question is that, did you find any recidivism in the authors publishing multiple fake papers in this case?
Yeah, we have never really looked at the authors very much. I think for some of our papers there are authors that have published multiple papers, but we've not focused on the authors. Really just the papers themselves, the errors within them, where they're published, and to some extent how much they're cited.
Yeah, for me it's because I want to give agency to the authors doing something that is bad in principle. And indeed I was thinking the second question is that, have you thought in your last publication when you will list the 5 items there, have you thought about punishment? Like what sort of punishment we can bring to the authors?
Well, I don't really think that much about punishment for authors. Those sorts of things have been described. One system is to provide opportunities for amnesty where you allow authors to come forward and say that they have published with paper mills, and if they do that within a particular time frame, they will not be punished. I think that probably to punish the paper mills, one of the best ways is, of course, to not publish their manuscripts, but if they are published, to retract them very quickly. The issue at the moment is retractions are so slow that they don't really serve as any penalty. So I think I would like to see the penalty at the level of the literature.
Thank you. Hi, thank you for this amazing contribution. I was wondering if you said you've looked into the impact or citations of these papers. I was wondering if you could tell us, are some of these even highly cited, and could you find any evidence that they are cited beyond the self-citations, beyond the group of authors that author those publications?
Yeah, that's a very good question. So that is one of the things that we're currently studying with our current grant. We're interested at the moment in papers in high impact factor journals. We have seen that some of the papers that we study are actually very highly cited. And I know I say this to the student who's studying this at the moment. So I've been publishing for 35 years, and I have 2 papers that have achieved 200 citations, and that took 20 years. So believe me, it's not easy to rack up lots of citations, and yet we see papers that have got 100, 200 citations after only a couple of years. I mean, that's astonishing. So at the moment, we're trying to understand how that's happening. We hypothesize that paper mills are deliberately citing their own work, but whereas self-citations ordinarily are very visible because the authors are common, in a paper mill setting, that's not going to be possible. So essentially, we believe that paper mills are generating hidden self-citations, and at the moment, what we're trying to understand is indicators of those paper mill-driven citations.
Get my steps in.
Hi, Ross Potter from Clarivate. I think one thing that would be really useful in all of this is having some kind of defector. So is there any, does anybody know anyone who sort of has worked for a paper mill or been involved with one, or even authors who have used the paper mill and sort of explained sort of what the reasoning behind their motivation to do that?
Yes, that's a very good question. And I think many people have I know people have tried to do that kind of thing. Not surprisingly, employees of paper mills are not very forthcoming in terms of their willingness to talk. Some of the research there have been very few papers published. There was a paper that was published in 2018 where some researchers talked to authors of papers that had been retracted for peer review manipulation. It was also difficult for those authors to actually obtain an acknowledgement from the authors that they had worked with paper mills. So I think when we've written our sort of description of the types of research that are needed, we recognise that this kind of research is very difficult. It may require some kinds of incentives for people to participate. Otherwise, they won't. But then we also have to think about the possibility that providing these incentives might alter the information that's obtained, particularly in settings where there won't be a lot of incentives for people to tell the truth, and it will be difficult to actually fact check the information that comes out. So I think it could be a very fruitful line of investigation, but there are quite a lot of difficulties, I think, in conducting that kind of research.
Hi, we have we wear many hats at our university. There's a massive thing about research culture, and we do have a group of researchers who are very engaged in it, and we do get emails into the library going, I've had this, I think it's a bit sus, can I check with you? And we'll look into it, and then we tell them, no, don't do it, but it never really goes any further than that beyond we pass it to our research integrity office. And I just wondered if there was a more central repository, or if one of the repositories you're working on is sus, so when we find things that are sus, we can then send to people, go, oh, we've identified this, or for people who are doing the meta research to say, maybe this is something to look at.
Yeah, that's a good idea. So do you mean things like suspect invitations to submit to journals, or? Yeah, I mean, I'm sure. Yeah, that's a good question. I mean, I don't know. I mean, I tend to use, Twitter was certainly that kind of space earlier. There was a lot of that sort of discussion that was taking place. And I think some of it does take place on social media, on Reddit, on other places. But you're right, there's not really a very good way of publicising this. But I suppose that's where we think that there's a role for, really quality education programs that at least tell, you can't tell people every example, but you can tell people, if you get an invitation and it looks like this, ignore it. I know that there's Think, Check, Submit for identifying predatory journals and Think, Check, Attend for predatory conferences. So there are resources available, but I agree that, they probably could be more visible, particularly to students and early career researchers.
Okay, we've got a couple of questions from our vast online audience. My colleague Yusuf's monitoring that.
Yes, I'm just voicing the first question. We have 4 questions. The first one is, do we need a database for publishing paper mills, like Retraction Watch that publishes retracted papers?
Well, Retraction Watch is doing a great job because they are, of course, indexing all retractions, including those from paper mills, and that's now a research resource. So I would argue that I think we've probably got a lot of the tools that we need, but probably we need greater researcher awareness of some of those. So people in this audience will know about Retraction Watch and will probably be aware of PubPeer, but if you ask biomedical researchers, many of them will not have heard of either. So we actually need greater awareness, I think, of the tools that we already have, and then supporting those tools such that they're as effective as they can be.
Thank you. The next question is, have any of the papers been retracted? What is the response of the journal editors when they are confronted with these problems?
Yes, the answer is some of the papers have been retracted. I would say that we probably had better responses back in 2016, 2017. I think now, as we describe, if we're describing hundreds of papers, I feel that the responses are probably worse. Responses vary. Some editors are fantastic, and some editors simply ignore us. So it's really somewhere between those two things. So for our latest paper, we described 420 papers with either wrongly identified cell lines or cell lines that don't exist in 235 papers. So we described those to journals, I think, it wasn't really very long ago, it was a few months ago. So far, I think we've had 5 retractions. So a few hundred to go. Yeah.
We have 3 questions related to paper mill citations, so I'm going to ask them in a row. The first question is, could you please expand a bit more on the hidden citations in terms of paper mills? And the next question is, I think based on the paper mills concept, the citation mills is also a relevant concept. Did you find a sign of citation mills through your investigations? And the last one about citations, building on the previous question about citations, is there any evidence of research from paper mills being cited in policy documents?
Yes. Okay. So I think the first question was really just about kind of the evidence of these paper mills citing themselves. I'd have to say, look, that's something that we're working on now, and it's difficult because generally, as I said, if you're looking at self-citation, the giveaway is the common author. So if you don't have common authors to guide you for self-citations, you have to find other unusual features of citations. And we have hypotheses as to what they might be, but we really don't know. I hope other people are studying this because we are also not citation experts. I'm a molecular biologist, so we're self-taught, but there are people who understand citations, and I'm sure that there's a lot of signals in the literature if people wanted to look. The second question was around...
The second question, did you find a sign of citation mills through your investigation?
Yeah, no, but we haven't looked for them, but I think, I mean, I'm sure that they are there. I think I know that there are, people have discovered citation mills in different countries, and there are ways to determine those, but generally those citation mills become apparent from looking at very large bodies of literature, and so you start to see small differences emerging. It's not something that we've done yet. Again, I hope people are looking at that. And the third question was...
The third question is about paper mill citations in policy documents. Have you ever come across?
Look, we haven't looked specifically at policy documents. We have looked at citations of papers with nucleotide sequence errors. We have found those papers cited in reviews, and we have found them cited in clinical trial documents. We've found them cited in Wikipedia. We've found them cited in patents. So they, they move through the literature. But in terms of what they do, their impact, that's another question. We haven't looked at that in a lot of detail. You have to really track the information and work out what this paper said, what this one said. A lot of the time what we find, the information is actually diluted as it's cited. So the impact of these things individually might be quite low, but collectively across a field, if we're talking about hundreds of thousands of papers, there has to be some impact, I think.
We've got time for one more quick question, if there is one. I saw your hand first, so I shall come around.
Thank you very much. I think I put my hand up to begin with. I knew what a paper mill was, but I don't think I did. So I found that quite shocking. And it kind of goes on from the last one about policy. And obviously, so for your discipline, you found around 4% of papers had some sort of red flag about them.
Yeah, it depends on the journal, really.
Yeah. Do you get a sense of what it's like in other disciplines? And I think with the policy thing, what I'm most concerned about is whether there are any clinical trials that are produced by paper mills.
Yeah, that's a good question. Clinical trials, I don't know whether paper mills are producing publications around clinical trials, but I think it's possible. There's probably other fields that are being that have been targeted by paper mills. I would say chemistry is one field, microscopy, but yeah, I think that one of the sort of more certain ways that paper mills are destructive is through just being a distraction. If there's so much poor quality literature, it prevents people from seeing the quality literature and then acting upon that. So I tend to think in terms of policy and translation, at the moment most of their impact is likely to be preventing the focus on the good stuff, as opposed to putting something forward that then results in poor policy. But of course, if paper mills change their tactics and change their capacity to produce papers with Gen AI, then we might see more immediate policy impacts, I think.
Okay, thank you ever so much again, Jennifer. It's been really interesting, so many good questions as well. Could everyone give Jennifer a hand?
There we go. You think after Zoom all these years I'd learn. Okay, so now I want to present Dr. Angela McGuire from Elsevier, who's going to talk to us a bit about AI-driven impact stories.
Thanks, Michelle. Thank you. Hi, everyone. I'm Angela McGuire, and I'm from Elsevier. So I work in the Research Collaboration Unit, and I'm really pleased to be here today. Thank you for having us here. So in the Research Collaboration Unit, we work with external institutions to Elsevier, universities and research institutions working on research problems that are coming up in the research evaluation community. So a bit of background about me. I now work for Elsevier, but before that I'm continuing the Australian theme, Jennifer. I used to come from a research office at the University of Tasmania in Australia, so a bit further south than Jennifer. Next stop's Antarctica, so it's pretty way down there. And so before that, I was also a researcher, so I used to study birds. So it was quite a trajectory that I didn't expect, but never mind, here we are. So at Elsevier, we have AI. It drives a lot of our solutions. We have been using it for many years now, and it's used for disambiguating author profiles, which I used to use when I was in the research office. I was a data analyst there, and so author profiles was something I used to use as well. We also connect the huge database that we have with Scopus. It says 70 million on the slide. I think we're up to maybe 90 million, somewhere around there. So it's increasing every day. We've also got the subject area mapping SDGs. I used to use them at Tassie when I was there as well, and subject area mapping. And then now we've got the new generation of AI. So we've got the Scopus AI, and happy if you want to ask questions, I can direct you to people that know more than me, but happy for you to talk to me afterwards. I love AI because it does actually help with the cold start problem, the blinking cursor. That's always a dread for me, so I'm really enjoying this new AI. Obviously there's dangers that we have to be wary of. So we are really cognizant at Elsevier of responsible AI. We really do consider the real world impact of the solutions on people. When I was working in the research office, I was analysing academics. Often they were my friends as well, so I really understood the impacts of the data analysis that it would have on their careers. I knew if they were having a baby or if they were having a career break. So we do really consider and take that the impact on board. We take action to prevent the creation or reinforcement of unfair bias. We can explain how our solutions work. We create accountability through human oversight, and we respect privacy and champion robust data governance. So that's the AI part. That's outside of my remit. My remit is working on piloting new ways to analyse data. And this is a project that we've been working on. It's the primary reason I'm here to talk to you today, is because we're piloting a new way to generate impact stories. So just to bring to the forefront of your mind that we all know this, but institutions, universities have 3 pillars often. It's research, then there's teaching, and then there's societal impact. And so this societal impact, there's been an increased emphasis on the societal impact. And impact narratives and writing stories has become an increasing custom in our world, in the bibliometrics world and in the impact world and in performance analysis. And it's really hard in impact to map nicely like we do in bibliometrics. The data that works in health, lives saved, doesn't necessarily work for environment, where you might be looking at national parks and acreage saved or species that have been protected. It's really hard to consistently map across these subject areas. Then you've also got geographic boundaries. What works in the UK doesn't necessarily work in Australia or Hong Kong or a different subject and different country. And then you've also got time boundaries, because impact takes so long to happen sometimes. So in health, for example, the magic number is 17 years from when the research happens and then until the impact happens outside of the university. So there's these time boundaries as well that can also make mapping hard. But then there's impacts that happen immediately. So if you improve an algorithm for weather forecasting, for example, and that helps farmers better predict the weather and they get better crops, that's an immediate impact. So it's really varied. And narratives are storytelling. And I have an academic background as well. I'm not necessarily a very good storyteller. It's not something that I'm trained to do. I can cite really well, and I know the scientific literature and that behaviour, but I don't necessarily know how to tell a good story, and I can't imagine everyone does. It's just it's sometimes really difficult to do, and it's really labour intensive. So we were trying to think of ways to we could find a commonality among geography, among time boundaries also, and across subject areas. And we thought perhaps there's research characteristics. So it's really small on your screen. When I was doing this yesterday, it was a lot bigger on my screen. But on the left-hand side, we've got some characteristics that we think cover stories and narration, and the way people describe their impact to their family members, how you go down the pub and you explain it to your friends, what's my research, this is the impact that it has. So we tried to identify these characteristics that we think could help impact officers and academics tell their impact story. And so these characteristics are significance. So what's the significance of your research and past the university? What significant problems would you be solving? And academics do. They know the significance of their research, otherwise they wouldn't be doing it. So it's about explaining that significance to others. Then we've got reach. What's the audience that you're affecting? Is it lives saved? Is it people with a particular disease? So it's reach. Then we've got novelty. What's the novelty of your research? Tangibility. What are the tangible outcomes that come from your research? Is it a change in an algorithm? Is it a software? Is it a vaccine? It's these tangible outcomes that aren't necessarily citation-based, but are beyond what happens in society and things that people use beyond the institution. And then we've got collaboration. Are you collaborating with industry? Are you collaborating with government? Then we've also got transferability. How transferable is this research to other areas? This could be a way that you could explain the significance of your research. If you've developed an algorithm that gives you a good recommender for, I've been a sucker to this, what's the next movie you want to watch? What's the next dress you want to buy? That's an algorithm that has transcended some subject areas. Policy relevance as well, and then we've got engagement. So what activity is happening around your research? So that's the characteristics on the left-hand side, and we think that these can help enrich your impact narrative. This is a way that you can describe, rather than summarising your research, but really trying to enrich your narrative with these characteristics. And then we have a narrative for each of the characteristics, and in this narrative it's generated from the publication abstracts. And then we bring data into it as well. So this is data from the CRIS systems, such as Pure, such as data that you have sitting that the academics have entered about the workshops that they've done, changes in perceptions that they've noticed. The Prime Minister spoke about my research, something, these other impact data points that they can talk about. So we bring that into the narrative as well. Then we've got the supporting evidence deep dive down the bottom, and that's just to help give impact officers and the academics some more information to talk about in their narrative. And then we've got the colour wheel there. We're calling it a widget. It's not meant to measure performance. It doesn't measure how well you're doing. What it measures is what might be there to talk about to enrich your story. So is there an indicator in there that will help you tell your story? And we've selected indicators that sit under each of the characteristics that we think are relevant to the characteristic. So we're piloting this at the moment. We're talking to development partners and just seeing if this is something that people are interested in. That's all I have for my presentation. Thank you so much for listening. Very happy to talk to anyone after the presentation, or we can ask questions now, Michelle.
Thanks, Angela. Does anyone have any questions? Yep.
That's really, really interesting. I'm just wondering, of the characteristics, is one thing that you've thought about limitations? Because increasingly in discussions in papers, authors are encouraged to talk about, how their story is limited by the data, and I guess it can be an indicator for future research. Is that something else you've thought about including, or? not so sexy, but you know, but important in terms of both selling and that sort of thing.
Yep, absolutely. And it's talking about the potential impact as well, isn't it? Which, because it takes a while to happen. Yep, that's a good one.
Is there anyone else? Yep.
I'm interested in this idea of, I like this idea of this color circle and defining these different forms of impact. Are there some of them that you're finding harder to identify than others? So I can imagine that things like tangibility, like novelty is one that I can see there are more or less straightforward ways of doing it, but things like maybe tangibility or transferability might be more difficult to figure out.
Tangibility is my favourite one because it brings the CRIS system data out the most, and things that, like the change in an algorithm and those sorts of tangible outcomes that you can talk about. So tangibility is my favourite, so that one hasn't been hard. What was the other one you said, sorry?
I don't know, transferability.
Yeah, transferability. Again, we're sort of assessing how important is it, transferability? Like, is this something that you would talk about in a narrative? Is this something that demonstrates their impact? But we're really open to feedback and talking about this further, and if this helps enrich your story, and if not, then yeah, we will think about other ways we can help enrich the story. Yep, thank you.
Thanks. I've got two slightly techie questions you may not have the answer to at this sort of early pilot stage. Thing one would be, would this come as part of the impact module, or would it be a new WYSI extra module?
Good question, Marin. I wish I knew. I don't know. We don't know yet. We're just piloting it at this stage and just seeing if it has any value and see, it might be. We found that the CRIS system really adds to the richness of the narrative, so probably aligned with something like Pure or something, because it.
That's my next question.
Yeah.
Were you planning to build kind of integrations with non-Pure CRISs, or is this kind of, or is it only going to work with a Pure system? Which again, I suppose you sort of answered.
Yeah, I don't know yet. Sorry. That would be something that we would look at. Yep.
Okay.
Thank you, Angela, for your talk. Very interesting. I'm wondering if you are aware if any UK university are adopting this or requesting this to researchers to provide this kind of information. Are you aware of any?
Thanks, Robert. Am I aware of any UK institutions requesting? Yeah. Yeah, well, we're talking, impact officers, when I was at the research office, we didn't have an impact officer, but they seem to be a new role that keeps popping up because there's so much emphasis on it now. So, yeah, we think there's increasing interest, especially from the UK, where there is a national assessment, and national assessments are happening in Italy and Hong Kong. So, yeah, they're more interested than non-research evaluation impact exercise countries. Yeah.
Okay, so I think we have some questions online.
We do only have one question. The current keyword Boolean strategy Elsevier uses to assign SDG labels to outputs in Scopus results in some false positives. I would be interested in hearing if you think AI can help refine results.
Excellent question. Again, I don't really think I'm qualified to answer. I'm not sure of the methodology currently used with the SDGs. All I know is that I'm the end user of the SDGs, but happy to, if that person wants me to find out, I can find out more. Absolutely.
Okay. Is there any other questions at all? Because if not, then it's time for our break. So if you want to head into the foyer, we are a couple of minutes early, so but there should be tea and coffee and things like that out there for you. Okay? So thank you very much.
Thank you.
Now? Yeah. Welcome, everybody. I hope you had a nice coffee break. Our second wonderful keynote speaker is Professor Caroline Wagner. Unfortunately, she couldn't be here with us in person today, but she kindly sent us a recording of her presentation. She also mentioned that if anyone has any questions about her talk, we could send her an email afterwards. So the title of the presentation of Professor Wagner is How Bibliometrics Can Inform Decision Making.
Leading far ahead of other nations in the top 1%. Thank you so much for. Hello, everyone. Thank you so much for inviting me to speak to the LIS-Bibliometrics conference this year. I'm Caroline Wagner, a professor of public policy at The Ohio State University in Columbus, Ohio. My work focuses on how bibliometrics can inform science policy and government investment. And today, I'd like to discuss cases where I worked with others and we reassessed some bibliometric measures to better represent the scientific dynamics for policymakers, and I show how the choice of measure influences the interpretation of the data. This is something that we bibliometricians really need to keep in mind. Let me share my screen with you so we can look at some slides together. So the first case I want to share with you is the case where we measure the top 1% most highly cited papers. Here we see this graph that was published in the National Science Foundation Science and Engineering Indicators. You can see that this graph shows the United States leading far ahead of other nations in the top 1% most highly cited. And the EU comes second there, and you can see China there in the purple, rising quickly, but still well below the United States in most highly cited. This raised some questions for us because we were working on Chinese capabilities in different fields and seeing that in a number of fields, China's work was represented in the top 1% most highly cited. So their poor showing in this NSF graph led us to ask a question about how it was measured. We used a different measurement, which I'll show you, and came up with a very different outcome. On the left, you can see the graph we published in Scientometrics together with Lute Leidesdorf and Lin Zhang. Here we find that in around 2016, China surpasses the EU and the UK in most highly cited, and then top 1%. And that in 2019, China surpasses the United States in top 1% in terms of numbers of articles. So how did we make this graph and why was it so different from the National Science Foundation's measures? So we take a different approach to measuring the top 1% most highly cited in these 7 different ways. So the first is field normalization. In the graph that we just looked at on the right, the normalizations were conducted by Scientometrics and SciVal. And the way they did it was they first had a field level normalization, and then that normalization took the top 1% from each field and aggregated it up from there. We suggest that kind of field level normalization can introduce errors in how we see the top 1% and may not accurately reflect the cutting edge research that we're looking for. These field designations were developed over decades and oftentimes represent historical representation of the knowledge system rather than a cutting edge view of the research. The second thing we did was we tried to avoid averages. In the field level citation, weighted citation analysis, they use average citation rates as expected values, where we know in scientometrics, right, that citation distributions are really highly skewed, and averages are invalid for non-normal distributions. Third is we looked at the percentile ranks, and instead of field weighting averages, we use percentile ranks, and we expect 1% of a random sample to contain 1% of those belonging to the top 1%. And so we measure deviations from this expectation. We also use whole counting for international collaborations rather than fractional counting. And we argue that better represents the access to the knowledge content, which is what we're looking for. We just take the top 1% of all the work from that country and look at the total number rather than by within each field. And then we conduct an expected over observed analysis and do some statistical testing, which I will show you in a minute. So here's the normalization that we used, where we compare observed values with expected ones. And so then we look at the observed over expected and specify the expectation. And you can see that the specification of expectation is different when you're using the parametric measures, which was used in the SciVal measure, against non-parametric measures, which is what we used in our analysis. And the paper is in Scientometrics. And we make the argument that using the non-parametric statistics is a much better way of assessing the strength of a nation. When we're comparing nations, we're not comparing fields of science or strength in fields of science, we're comparing nations. And we recognize the skewness of these bibliometric distributions. And the categories have been developed over many years, starting 40 years ago. We question whether that even field designation is useful, but we abandon it for the purposes of creating a top 1% most highly cited. And here you can see the actual numbers that we did. And you can see that 1% of the nation's papers would belong to the most highly cited papers, right? Here you can see on the left, the nations or regions, and with the number N is the number of articles, and you can see that. And then the percent top 1% expected. So that's just a simple measure, right? The simple 1%. What is the 1% of China's 504,000 articles? About 5,000 articles. And then we look at the percent of top 1% actual. And here we find China is performing well above expectation. And then you can see that in the far right column. And then you can see very clearly that China comes up ahead of the United States, the EU 27 and EU UK in the years that we examined. And so this shows it for domestic and international co-publications for China and the USA. And here we can see that the sum, we see China ahead of the USA in the sum and in the domestic. And we know that Chinese scholars oftentimes lean towards citing their own country's work, which is fine, but that's the choice. And so we know that there's going to be some bias in the numbers. And when we look at the internationally collaborative work, we see that it's indeed much more represented in the top 1% than either domestic or the total numbers. So that shows you one example where the way in which it's counted will have a great influence on how policymakers are thinking about the outcomes of scientific research and development. In this case, the NSF graph might be giving people a false sense of security that even though China was producing a great deal of work, their quality wasn't there. And that is really highly questioned in the work that we did, showing that, in fact, when you look at just China only, USA only, China was performing very highly in top 1%. The other thing I think it's important to note is that when we look at the US-China together, we see that the work that the US and China are doing collaboratively is even more highly cited and more represented in the top 1%. So the collaborative work is having greater impact than the work of either nation alone. So the second case I want to bring to your attention is a very recent one. It is work on China's technological prowess by the Australian Strategic Policy Institute's 2-decade-long critical technologies tracker called the Rewards of Long-Term Research Investment. And it recently came out and caused some people to take note and ask questions about what they are finding and the validity of that finding. This just shows you the graphic of China's increased in output in science and technology. China rises from very low representation in Web of Science in the 1990s to the point where by 2023, China outperforms even the US, which is in gray, in terms of percentage share of their work and the numbers of articles in the Web of Science. The blue line shows China's international collaborations as a percentage of all the work, showing they've always been highly international in their orientation of publications, although it drops in the 2020s, partly because of political issues, partly because of the pandemic. So you can imagine that this kind of a graph is going to capture attention among policymakers, noting China's rise to the dominant producer of scientific outputs, beating the United States, which has held the top position for decades and took that top position from the UK in the 1940s and has held that position ever since. So this is creating some cause for concern in and among US policymakers. This shows US-China co-publications over a little more than a decade. The significance of change here is that in 2010, China and the US were increasing collaborations. In 2013, China surpasses Canada in numbers of co-publications with the United States. In 2015, China surpasses the UK, our top partner, United States top partner, and becomes the top collaborative partner with the United States for the remaining years here and remains the top partner for the US, even though we see a drop-off in publication work. The top line shows the percent cited of all that work between China and the United States and shows that it's been highly cited work even since 2010. And we see a drop-off in the 2020s, but that's probably due to just a delay in the work being cited and counting that into the numbers. It's not necessarily clear that reflects an underlying dynamic that's of concern. So here's an example from the Australian Strategic Policy Institute's report on China, in which they break it down by broad categories and then by sub-technologies. This is in one of their graphs, Advanced Information and Communications Technologies. They have that second column there that has what they call a technology monopoly risk, where they assess the extent to which a country, in almost all these cases, it's China, poses a risk of assuming the position in the world of having a monopoly on the technology. So you can see here that advanced optical communication has a high monopoly risk because China, in their count, has 41% of all articles compared to the US with 11%, and so on. Here's another example where they show advanced materials, artificial intelligence, and so on. And we take a different approach to their critical technology assessment and really question the validity of their approach. First of all, we only examine articles, not all documents. They used Web of Science core collection, and so did we, but we only focused on articles, citable articles, not all documents, including reviews, letters, conference papers, and so on. We also do not limit our work to top 1% or top 10% most highly cited. We use all articles, and we separate the countries in our search so there's no overlap. You can see that the overlap really changes the citation count. When the US and China are working together, that work is much more highly cited. So we did a search where we have USA only, China only, and then together. And then we normalize the citations by R&D workforce, the size of the R&D workforce. We examine at the subfield level because at the field level, the numbers are very large. And when you have that kind of large number, it's very hard to get a good assessment and to get a decent average. So what did we find? Here are the categories that ASPE developed. You can see that. And then they have the subfields where ASPE has assessed China to be in the lead. And you can see there's no field where China isn't at least 50% or more taking the lead in the assessments. So on the left, you can see ASPE's methodology. And on the right, the assessment method that we used, where I just outlined articles only, country only. We didn't do attribution questions, about 50-50 split, because that's a small percentage of the work. We took all articles. In a couple of cases, the numbers were large, very large, and I couldn't get Web of Science to give me an average citation. And then they used a 21-year period, and we limited it to the most recent 5 years. Now, when you analyze with average citations by subfield, it shows quite a different picture. Here's the critical technologies field across the top. The starred ones are ones where I took the highly cited papers only, which were in the hundreds in terms of numbers. And it shows USA citations. Green is the top, yellow is middle, and red is bottom. And here we see USA citations coming out on top in a number of these subfields. And then China-US collaborative work bettering just China alone. Again, you can see there are cases where the two countries working together are in the most highly cited category. The second part is testing this idea of monopoly risk. So let's just take one area where ASPE assessed the greatest risk in terms of technology monopoly, and that is synthetic biology, where they identified a 10 out of 10 risk and showed that China had 57.7% of all articles compared to 13% for the United States. So let's just look at synthetic biology and examine that one. So here are synthetic biology articles, shares by country, just country count. And you can see for technological or scientific leaders, China and the USA share the top number. And so that puts to question the count that they have of 57% China, 13% USA. And you can see China and US share about the same number of articles. And then with Germany and England being the next level of capacity in this field. Then we normalized the shares by R&D personnel per million. And again, here we see synthetic bio. Still, we see China holding a significant share of the pie here. But when we normalize by R&D personnel, we see capacity very broadly shared across numbers of scientific nations, putting to question the idea that any one nation would hold a monopoly over a certain kind of technology at any point. And therefore, the question of what a monopoly means has to be raised. So hopefully I've demonstrated, at least with these two cases, the kinds of questions that will come up when we make choices about measures. As we make those choices, it's important to consider how a policymaker will respond to that, because we're trying to give them a clear idea of the underlying dynamics. As we make choices, we really do influence policymaking and inform decisions. Thanks again for asking me to present. Here's my email address, wagner.911@osu.edu. I welcome questions, comments, and offers of collaboration. Thanks again, and I wish you all a very wonderful and enlightening conference.
Thank you to Professor Wagner. She raised a very important topic in bibliometry, so looking behind the numbers and indicators. So now we have the parallel sessions. So we have a session here in the lecture theatre, and we have also a session in 407. It's on the ground floor, near the entrance. So if any of you would like to stay here, there are going to be sessions, or if you want to move to the other rooms, it's also fine. Now is the time. And if you would like to email Caroline, please go ahead with any question virtually or in person that you have. Thank you so much for attending.
Welcome back, everyone. Let me introduce our next speaker, Andrew Gray. He's from University College London. He is Bibliometric Support Officer. He had recently published today's presentation on archive. I'm sure he's going to mention about that. The title is ChatGPT Contamination, Estimating the Prevalence of LLMs in the scholarly literature. So I'm now handing over to Andrew.
Thank you very much. I feel that calling it ChatGPT contamination is going to betray my opinions about this whole thing, but let's go. Okay, so as Yusuf said, this started from some research I published a few months ago, but we're going to look at some sort of broader aspects of the field as well. So ultimately this question comes down to, there are AI-assisted papers out there. How can we find them? What methods can we use? So we're going to look at why we did this study, what methods there are that other people have used, that I've used, how many papers are we actually talking about, and how much of a problem this actually is. That last slide got retitled a few times. It originally was a lot swearier. But the short answer is I think we are in a bit of trouble. Okay, so part one. If you all think back to about February of this year, I think you may well have seen this particular bit of text floating around Twitter. So this was a paper that has thankfully now been retracted, published in a otherwise perfectly mainstream journal, in which someone had clearly just asked ChatGPT to write the paper for them, had got a response, and had not even read it to find out that ChatGPT had said no. Following this, their publisher had not read it to find out that ChatGPT had said no, and had pressed publish on this without ever noticing. And then it was up for a few weeks before someone read it and was like, wait a second, this is a problem. And like any reasonable researcher would do when they found something that was a problem, they put it on Twitter and laughed at it, which was great because it meant that we all started thinking about this problem. So people looked at this. They found a few more cases of this. I think in February there were about 5 or 6 of them that people found, which had things like this in it. As a large language model, or certainly, here is a possible abstract for your paper. It was great. It was really wonderful. It was very, very funny, which is the important thing here. But it was also quite concerning. Sorry, I pressed the wrong button on this somehow. I can't use PowerPoint. Okay, so we got to part 2. I've said delving here because it turned out that delving is interesting. So obviously I said there were 5 or 6 of these papers. Great. We can't find any more of them. There probably are a lot more out there published by slightly more sensible people who remove ChatGPT from it. A study that came out in March by a group in, I think, the US, found that AI was being used to write peer reviews for conference papers in computer science. And they've detected various things about this that made it clear it was AI. But one of the things they mentioned is the AI text used certain words much more commonly. They were generally quite positive words. I think almost all of them were positive, one neutrally toned. And then it occurred to me, great, do the actual papers use those words more than older papers? Really simple question. We've called this delving because someone else did the same question and discovered that delve is a word that AI loves. And it turns out the answer is very much yes. So these are the relative frequency at which this word changed in all papers in the world, in dimensions, in full text, from 2016 onwards. So for every year, they all trickle along, going maybe up or down by a percent, by a couple of percent, and then suddenly, boom, through the roof, which is really quite scary. So commendable appears basically twice as often as you might expect. Meticulous 1.5 times. Intricate twice as often. This is very scary. So having found this on a Friday afternoon, I spent a bit of time over the weekend working on it, got very angry, spent most of the weekend writing, and managed to put something out. So what we did was we tested 30 words of these. So this was 20 of the words suggested by this other study, 10 control words like red, green, blue, Found 10 potential marker words, which had a significant change. Strong words, medium words. So some of these went up by more than 50% year on year. Like they were, other people do statistics by looking for p-values, by looking for complicated things. I look for graphs you can see from space. So these are not subtle changes. There is no other explanation for these. We suggested that based on previous growth rates, we would expect maybe 100,000 papers would use 2 or more of these words. We actually found 160,000. So that's 65,000 more papers than there ought to be using those 2 words for no apparent reason other than AI uses those words quite commonly. 2024 numbers didn't go into detail because trying to get a baseline for 2024 in March was quite difficult, but the indication was going way up. So this makes it reasonably clear that something is definitely going on here. We have these words. The words are a lot more common. There isn't really any plausible explanation for it other than the use of tools like ChatGPT. I mentioned earlier, these are all positive words. One thing we found really, really interesting is this original paper, Liang, said there were 50 words they identified as disproportionate, 50 adjectives. 47, 48 of those were positive adjectives. The system really does not like generating negatives. We could not find a negative that was overly represented. We couldn't find, I found it really hard. I tested various random words, could not find a word that was actually less common in AI text. And much, much later, I spoke to someone who'd done some similar research a few months further down the line. And remarkably, the words that are less common in AI text are mildly positive words. It doesn't like using the mildly positive ones. It wants everything to be groundbreaking. Very interesting. We did find, incidentally, that there were words that just were going up by 5 or 10% a year all the time because they're fashionable words to use in research, which is quite fun. But even then, they went. So this is not a good result. This is very concerning. And this got a lot of attention. This is the first time in my life I've ever been contacted by a journalist wanting to know about research I did, which was quite alarming because I'm not really a researcher, I'm a librarian. There was quite a lot of discussion about it. And at the same time as this, I think 4 other papers got published looking at exactly the same thing. It was a big thing in Easter this year. And we all got some various different numbers, but all of them said something bad is going on. So this moves us into part 2 of the talk, which is what methods can we use to find this stuff? So the first of these is the explicit signatures as a large language model. Not very common. The second of these is the corpus analysis that I've looked at here, looking at the whole, everything that's written and seeing what patterns emerge. The third is explicit AI detector tools. These are the sorts of things we use for things like student plagiarism. And fourth is other non-textual features. So certainly earlier versions of ChatGPT, I think it has improved now, and of other tools, because they weren't tuned to work with scholarly papers, they did things like create citations that just sounded like a journal article without actually existing, or would create something that looked like a DOI in that it was a big long string of random numbers, but of course didn't resolve to anything. So in theory, you could use those as a detection tool. Running through these in order, the first of these is the explicit signatures. These are the most obvious. They are completely unambiguous, completely undeniable, easy to search for, and everyone, I said widely noted, I think widely mocked would be a better way of putting it here. We notice them really easily. 99.9% of people on the negative side are smart enough to find them. And are not going to leave it in a paper, even if they have intentionally generated it with an AI tool. Similarly, almost every publisher will also spot them. You would not expect many of these to filter through. So very, very few examples make it into print. It doesn't really tell us anything about how many papers are being written that way. If we look at a corpus analysis, it's a really simple process. I did this just by running searches on dimensions and comparing some numbers. The effects are potentially very visible. And there's a large range of potential marker words. So earlier, I looked at just some adjectives that have been identified as possible. We I say we, myself and some colleagues I was throwing this around with, just randomly plugged in some words to see if they would have an effect. We discovered that there is a disproportionate increase in the use of the word out with, which as someone from Scotland I find incredibly interesting, because nobody not born and raised in Scotland will ever use the word out with, but it's showing an increase, broadly consistent with the AI increase. So either the entire scholarly publishing literature has learned the correct dialect to use, or the tool likes it. We don't know. But it can be confounded by things like changes in writing fashions. If we all start using certain terms, it's going to show up. It doesn't specify which papers are affected. So a lot of follow-up questions I got was, can you give me 100 AI papers that you've identified so I can look at an analysis? We don't know. We can tell you there's a lot more than there ought to be. A later paper published on this, using this sort of approach, talked about it as looking at a sort of public health situation. You see that so many more people have died after whatever happened. That thing was obviously bad and caused more deaths, but you can't say that any one of those deaths was due to it. And it can't distinguish between stuff that was written by an AI, generated by an AI, versus stuff that's been translated or been polished. And of course, those are very, very different use cases. If something's been written from scratch by the tool, that's very bad. If it's been written by a human and then just cleaned up or tidied or grammar checked or translated, that's a much less of a problem. But the text looks the same in either case. You can use the AI detector tools. Potentially, these are the most versatile. They can identify a whole range of things, so not just word choice, but other patterns that maybe aren't apparent to a human. I don't actually know what a lot of these are. They're very black boxy. I wouldn't be surprised if it turns out that some of the tools really like generating sentences of exactly this length or something, you know, things that we'll never pick up on as a human. And if they work correctly, hard to get around. However, again, there are problems. We can't use them at a large scale. We have to assess each individual paper. And, you know, in some cases we can do that, but that's computationally very expensive. Actually getting the full copies of every paper is difficult. Generic AI detector tools, I think a lot of us played with them way back when they first came out, when ChatGPT first emerged. And I was certainly told that things that I had written were written by AI, because a lot of the time it's tuned to look for a certain style of writing. It finds that neutral and dispassionately written things tend to show up as potentially AI generated, but that's of course what we're aiming for in the scholarly literature anyway. So it's tricky. So there's a lot of variable quality, there's a lot of opaque methodology. We don't really know how a lot of these tools are working. A lot of them are very much a running target, trying to keep up with developments in the language models themselves. So it is tricky. And finally, the non-textual ones. So there hasn't been that much work on these, I think, but they can look for features that are distinct generated text, not copy-edited text. So structuring, for example. Or, as I say, things like generating references, generating fake DOIs. A human's not going to do that, but the tool might if it's not well put together. However, the publishers will catch a lot of these. If you're editing a paper, you're going to say, well, reference 16 doesn't exist. Can you just go and correct that? And they are challenging to search for. So I think these might be more useful if we were to look at just things like preprints or just look at things submitted to journals. But of course, that second part is a lot harder to get to. It's much more difficult to run a search on a general publications database and find some of these things. I mentioned AI-generated images. We've definitely seen patterns with that. Again, trickier to do as a sort of large-scale database search. So, for my mind, this is probably still the most effective approach we have for finding out the scale of the issue. But there are other approaches available. So what is the scale of this issue? So these are 4 studies done on it in the last 6 months or so. The first of these, Liang, is the one looking at conference peer reviews. It just looked at peer reviews, but of course, people who write peer reviews tend to be people who write papers. And it said 6 to 17% of peer reviews in computer science in 2023. Highest numbers in AI fields. Make of that what you will. I found 1.15 to 1.65% of articles. numbers were a bit vague depending on which set of markers I used, and rising sharply. So my numbers are very conservative. I'm only looking at a small number of marker words. Liang did a second study looking at preprints and just looking at abstracts. They said up to 17% of computer science preprints on arXiv showed AI fingerprints. If they looked at Nature portfolio journals, actually papers published in those journals, just in the abstracts, 6%, which is lower, but still a lot. That's early 2024. And Kobach, which was published in, I think, about June, looked at PubMed. It said about 10% of all PubMed published abstracts in 2024 had markers. So Kobach used a quite clever approach where they, rather than saying, we think these words are AI, they took the entire corpus of what abstracts looked like 5 years ago, the entire corpus of what they look like now, and then started looking for marker words in terms of the difference between them, which was a really smart way. And it did mean that they could find things like words that AI uses less often rather than more often. So that one, I actually meant to put little links in here, but that one was really, really fun. And just to put that in context, I've said 10%, 1.5%, 6%, whatever. Globally, we're looking at somewhere between 2 and 5 million articles published a year in all fields, where these are, these numbers may sound small, but if it's 10% of all papers, all abstracts in PubMed is 1 million or so that's 100,000 papers. If it's 10% of everything published, we're talking, significant fractions of 1 million. That's a lot of people who are using AI. I also looked in full text, I didn't put this on the slides, for people who mentioned AI-related terms in their papers. Almost negligible. So among the papers that had disproportionate use of AI marker words, very few of them said anything about ChatGPT or large language models or AI or anything like that. But it's not just the numbers. So the first Liang study, looking at peer reviews, found there were other patterns in the papers they thought were AI. They said that reviewers submitted them closer to the deadline. They were less likely to engage with any follow-up correspondence, and they were less likely to give a very confident, this is a great paper, this should be rejected, whatever. They were much more likely to be a bit waffly. In their second study, looking at papers, they found that AI-marked papers are more common among people who publish a lot. This is perhaps not a great surprise, but you can see where we're going with it. They found it's more common in more crowded research areas, so quite busy ones, and in shorter papers. So all these are what you would expect if it's being used to just generate a lot of stuff and get it out there quickly. So these are concerning, I think. And finally, how bad might this get in future? So some indications that we have suggest that more than 10% of papers in 2024 may be AI involved in some way. There is significant variation within that by region of publication, by discipline, by publisher. So by publisher might indicate different editorial standards. We know that some publishers have much firmer rules on this than others. Some of them may actually push more back on it than others. In discipline, we know that computer science is really big on this. We know that engineering is really big on this. We assume it's less common in things like history, but we have evidence that some of these AI-assisted papers may be materially lower quality than the non-AI ones. So we've got a rapidly growing thing in many fields that is not great, that is of lower quality. We found very, very low rates of disclosure. So as I said, I looked for papers that in my sample of ones that I thought might be AI assisted. They just didn't mention anything about AI in them. So it's not like these are being mentioned in a methods section somewhere. We don't have agreed standards from publishers on what there should be. There have been some moves towards this, but that's not yet materialized. Individual publishers have their own individual rules. And some of those rules were set back in November 2022 when we didn't really know what this sort of system was going to look like. And we don't have foolproof methods of finding it. So it's not good. It's not being talked about. It's everywhere. And we don't know how to find it. So combined, I am not very keen on this, I have to admit. So where do we go from here? We do need, I think, clearer guidelines and expectations. I said from all parties. Potentially publishers are the biggest, the ones who can have the most effect here. If publishers make clear expectations and have a clear commitment, then maybe people will have to follow that. We're probably going to end up with some kind of statement runs along the line of my second point here. There must be a human involved. That human must take responsibility, including if you've copy edited it with a tool, you should go back and check that it's saying the right thing. My absolute nightmare is that the tool is going to do something like take a medical case report and just make up the fact that all of the subjects were healthy adult males aged 18 to 25, because that's the bit that usually goes in there. And then everyone building on that picks up this completely fictional detail and goes from there. So people do have to go back and look at it after it's been copy edited to check that it's not done weird things. We probably will have some kind of guidance that says it should be disclosed in a transparent fashion. And it might be that we end up normalizing that in the same way that we normalize things like conflicts of interest. It's pretty common now that publishers will say you must have a conflict of interest section, even if it says there isn't one. Similarly, many publishers will say you must declare where your data can be available from, even if what you say is, well, there isn't really any data in this paper, or it's, you know, it's pulled from this public source or whatever. There should be a data declaration in some way. Whether this will happen, I don't know. I think this is what's likely to happen. But what we're seeing in the last year or so has been quite concerning. And we just don't know how much of this stuff is out there. As I say, we have these bibliometric approaches. But we're kind of flying blind, really. Yes, so thank you. I think that's my 20 minutes or so. I don't know if anyone has any questions or just wishes to say, this is terrible, I'm very sorry.
Thank you very much, Andrew, for this great presentation. So I will take, before taking questions, I should make a quick announcement for our online audience. We do have another parallel session, but it's not live streamed, but it's being recorded, so it should hopefully be available on our website, YouTube channel, LIS-Bibliometrics. So please check it out after the conference. So if anyone has any questions, okay.
Thank you. I was just wondering if any of the papers looked into the regions in any great detail, or if it is just looking for the words, because we're seeing quite a bit of people using it as translation, and it's like, so they've legitimately written their stuff, but they're translating it, and it's how do we identify good use of AI and the very, very bad type?
Yeah, so there has definitely been some look at, I think the Kobach paper I mentioned has also the Liang paper. I did some very cursory analysis, and you can definitely see some patterns emerging. The Liang paper and the Kobach paper have definitely got some quite detailed things on it, and it does break down in interesting ways. So they did things like looking at the, if memory serves, one of them looked at the affiliation address of the lead author and so on, and worked from there. There were definitely patterns. There's a recent study, which I cannot immediately remember the author of, but I can dig out, where it found that there were material improvements in the writing quality. It didn't look for AI generated papers, it just ran them all through a sort of writing quality, one of these reading level testers, and found that from some regions, it is the quality of the written English has materially improved in the last year, which suggests that the use of the tools is improving the quality of the translation, which is really impressive. I think the translation use is great. It's going to be really interesting to see how we say things like, well, how much do you still have to go back and check that it's because if we're worried about copy editing, is it going to change things subtly? And translation can be a real minefield. And when, I think if you're using it as an assisted translation tool, that's going to work really well. If you're using it as a complete translation tool where the author isn't necessarily going to read the translated work, then it's a lot riskier, especially for very technical fields. But yeah, there is definite regional markings.
Thanks, and a really interesting presentation. In terms of, I think you're right that an intervention is, publishers asking authors to declare their use of these kinds of tools, because of course the use in and of themselves isn't really an issue. It's the failure to declare it that makes things ambiguous. But I think often publishers, if they're not very explicit, they might include instructions to authors that authors then kind of ignore, or that they're not incentivized to follow. So I think I've seen some suggestions where, submission systems could request the declaration about the use, but then also tick a box to say, if you haven't declared this and your paper is subsequently found to have been, used something that you haven't declared, your paper's going to be immediately retracted. So sometimes thinking about, trying to encourage people to declare, but also imposing consequences for failure to declare when there is that opportunity.
I like that idea. I think there would be a lot of screaming and rending of teeth if that was... I like the idea. Do we have things where we have similar declarations like that in the systems already?
I think some journals are starting to do that.
Yeah. Because one of the things I'm thinking of is it is going to be that question of normalizing it. If it's in there like a data declaration, like a conflict of interest, where it's an expected part of the paper, then it's always... there was a study done about 5 years ago on the effects of the PLOS did a thing where every paper had to have a data statement. And they had a study looking at the effects of that. And the effects was everyone had it. Whether or not the data was actually available was a different question, but they did at least put it in the paper, put a statement in the paper to that extent. And of course, there are reasons that data can no longer be available or whatever, but making it a thing that they had to be aware of and had to pay attention to did motivate some change. I guess the other problem with that would be proving that an AI tool had been used. Because you could just say, well, I just always write in this incredibly cheery fashion.
I just wanted to chip in a little bit on this conversation. 1 week ago, I submitted a paper to Information Processing Management from Elsevier, and there was a declaration there. So they wanted me to declare and at least be aware that I am the ownership of the text, even though I used any generative AI. And so it's happening. And I've got a question actually for you. Thanks for the talk, and also a comment. So where do you draw the line? Because generative AI can be used for any sort of thing, like from finding synonyms to just translating, or generating whole sections. So what's good and bad in there? And then my comment is, it's really frustrating because I used to love the word delve. And then at some point, my boss came to me, Angela, you should stop using the word delve because now it is flagged as Gen AI. So yeah, thank you.
Delve is amazing. I didn't pick it up originally, but it is about the strongest marker word that anyone's found. It's really impressive. Drawing the line is hard because at some point we're going to have to acknowledge that pretty much like the grammar checker in Microsoft Word is to some degree a large language model driven tool, or it's going to become one in time. We have this discussion as well with, putting my normal librarian hat on, things like we say to students about using things like AI-assisted search tools. At what point do you draw the line there? And if we're saying don't use an AI-assisted search tool, then what happens when, these things are being silently integrated everywhere and they don't even call it an AI-assisted tool? I don't know. I don't know, and we are going to have a great fun in the next 10 years as a sector figuring this all out, I think. But we're in this odd situation where at the moment you can use it for pretty much whatever level you want, and it's your own honor deciding that this is enough. This is enough that I don't need to disclose it. I think it might come down to something like, has it actually produced text? Produced like a sentence that is in there? Has it tweaked your text? Maybe not, but are there actually words you did not write that are in there? That might end up being the threshold, I don't know.
Now we have just over 5 minutes to our next speaker, so I'd like to ask some online questions. We have 2 related questions. First one is coming from Karen Rowlett. Are the papers that feature the marker words from authors' countries that might be non-native English speakers? They might be using AI tools to help with language. And the second question is from Midrar Ula. Can I share my text with Gen AI for improving language?
So the first of those is, as was discussed earlier, yes, they are, but it's not universally. It's not like these aren't also coming from around the world. There are some areas where it appears to be more prominent. But I mean, when I did the initial tests, it was almost like some areas were actually being driven by a couple of individual people, for the marker words. You would find that there was a spike in the particular use of 2 words, and it actually came down to a couple of researchers who were, I didn't want to name names, but there was definitely some people who seemed like they were trying it on. So yes, but it can be confounded by other factors. The numbers that we were getting for individual marker words are quite small, so it can be really skewed by the numbers that you get from individual cases. In terms of sharing text from Gen AI, I mean, I think we then get into the complications that I know some places, some organizations are cagey about sharing text because it's disappearing into the training models, and you don't know when it's going to reappear again or what use is going to be made of that. I know that some places will have IP policies that would be, I'm not saying they would prohibit it, but they would look a bit concerned at the thought of that. And again, then it becomes down to the question of, well, what's improve? If you say, rewrite this to be completely better, are you willing to go through it and confirm that it is saying the same things you wrote in the first place? If it's, can you make this flow a little nicer? Maybe we don't need to do quite so much supervision of it. But ultimately, it's your paper, it's got your name on it. You're the one who's going to have to be responsible for it when someone comes back and says, well, these numbers are strange.
Thanks very much. And the next question comes from Behruz Rasuli. What are the potential long-term effects of LLM-assisted writing on the evolution of academic language and style?
I'm scared about this. I'm very scared. So there are 2 things. One is that we know there are secular changes, like regular changes in how we use language in scholarly writing. So we can see that like year on year back in the 90s, certain words become more popular. And part of this is people read papers, they pick up the style, and there's a real worry that if 10, 20% of our papers are now AI assisted, humans are going to be looking at that and thinking, well, this is what a paper sounds like. This is the style I should write to. Whereas 20 years ago, they were looking at their supervisor's papers and thinking, I've got to sound like them. Now, maybe we're all going to I've got a colleague who refers to it as sounding beige. We all start sounding beige because we're all trying to write to this model of what AI sounds like we should be. But there's also the problem that it's going to be affecting AI itself. So there's a phenomenon that gets talked about a lot in AI fields or in large language model fields of model collapse, essentially where you feed something on the text it's generated, and after a while it starts getting a bit weird because it's essentially exaggerating the features that it's detecting in its input model. If it thinks that all scholarly papers are a good source, if you've got a language model that's being trained on scholarly papers, but 20% of those have already been generated by a language model, you're going to get those features becoming, like, are we all going to sound, these are positive words, are all our literature reviews 10 years from now going to be like this, in this groundbreaking paper, in this breathtakingly staggering work of wonderful genius, because it's just reinforcing itself and reinforcing itself. I don't know. Maybe that won't happen. Maybe it will. Maybe we'll find out in 10 years' time. But it's scary.
Yeah, thanks very much again. And maybe we have one more question. Do you see any policy and practice change for REF, I guess, as a result of wrongful usage of AI in the UK?
Was that, sorry, for REF, did they say?
Yes,
yeah.
The question doesn't specify that.
I don't know. I mean, it depends what we do. I think before we can say wrongful use, we need to have policies that say what wrongful use is. And right now, we don't really have that many of those. So we've had a bit of a free-for-all for a year or two now where people can more or less do what they want and they haven't been told no. So that might not become wrongful use. I think we will be in a situation in a couple of years' time where we are looking back at this and going, well, that's not a good paper. That isn't. I don't know how we're going to deal with that. If stuff is retrospectively considered not appropriate, that's going to be a challenge for someone who I'm glad is not me to deal with. But it is going to be an issue. And we're going to be finding these things for a while yet, because a lot of these tools rely on the tools not being very good. As they get better, they become less obvious. And once they become less obvious, we're going to have to start using features like we were talking about earlier of finding the actual problems in the research, not merely that they sound a bit strange. I mean, right now we're actually in a good situation because we can find them easily. But
yep, thanks very much, Andrew, for this scary presentation. Now I'd like to invite our next speaker for the lightning talk. Our next speaker is Kate Lapage. So she's gonna talk about making our metrics service less about metrics and more about service and support. So I think she wrote this paper with her colleagues, but her colleagues are not among us. So she's the only person presenting this paper. So I'm now going to hand over to her.
Hello everyone, sorry, technical difficulties. My name's Kate Lapage, I'm from the University of Southampton. This is very UK based focused. It came from, we had a get together of various universities about talking about our metric service, and there seemed like a lot of people who were at the beginning of developing their service, so we thought we'd share our experiences, so hopefully you don't have the same mistakes we did. So we're going to talk about where we started, what we've done, and what we're our lessons learned and what we plan to do next. So the background is we had a restructure to our library service in 2021, and we are a new team. None of us had metrics background. We're all from a librarian background. We've got various different research backgrounds. I do open research. We took over from a service that had been run by one person who'd been doing it for a very long time, and everything had grown organically. And it was very, very technical. It was also called Bibliometrics, which I'll go into. And we had a training course which had flipped learning, that the feedback was that the people who came to the courses didn't do it and therefore got very confused in the training course. And the course wrongfully got bad feedback when it was actually a very good course. So our first goals was rejig everything and also try and improve engagement with senior leadership about what their academics are actually putting in our repository. So the website we had it was hard to navigate. You had to know what you were looking for to find it, and most people don't know what they're looking for. So what we set about doing was simplifying it. We decided to come up with a set of brilliant basics. Basically, if everyone in the university looked at our web pages and read them, they would be able to do the base level of what they needed. We renamed it as Assessing Research using metrics, because most people in the wider university community don't know what bibliometrics mean, and they would therefore get confused. It still roots as bibliometrics because we had to keep the rooting, but we assumed nobody knew anything and then built up. It's a lot of signposting now. The course, so this is just what some of the website looks. We've tried to keep it as simple as possible. And we've tried to integrate like thing links and stuff to expand upon, and links out to further sources. And come and talk to us. We want to help you. Don't try and do this yourself and get it wrong. So our training course, we had flipped learning. They weren't doing it. It was all in person, and it went into a very high level of detail of analysis that we've found that a lot of people don't actually need. So again, it was that coming up with what's the brilliant basics, let's make it an introductory course. It's online and in person. In part, that's because of the pandemic. It forced it to be online. We don't have any pre-work. The only thing we ask them to do is have examples of their own work or examples of their supervisor's work. So when we go into looking at the systems, they've got something that means something to them. And we've done very simple slides. And then again, it's a lot about signposting to come and talk to us or look at this resource. So these are just an example of some of the slides that we use, and we talk through them, and they like colourful diagrams for some reason. We have an idea of breaking down the question of what they're trying to do, and this seems to work quite well with people who are very beginners at looking at metrics and assessing how their work might be being received. And then that's all the ways they can get in contact with us. So the lessons learned, we initially just had it as anyone could come along. Last academic year, we took the decision to split the course out between postgraduate researchers and staff, because postgraduate researchers were often coming because they wanted to hit their learning quota, and staff came because they had very specific questions, and a staff member would ask a question, and then we would get tumbleweed because the PGRs were scared. So when we split them out, we started to get that the PGRs would engage a lot more, and we also started to find out what we thought was happening, but they were more willing to say it, which is, my professor tells me I have to publish in this journal because it's got a high impact factor, not because it's the right place for my research. So we've been trying to support them in ways that they can have that conversation with their professor. We've also discovered that a lot of the I need metrics reports are not. They just need a list of their publications, which has a citation or a normalized metric on. So it then becomes more about hand-holding in terms of responsible metrics and the best way to use it and all this type of thing. Still way too many questions for I need my H index, and why is my H index different on Google Scholar than it is in Pure? We use Pure as our Chris. The vast majority of the higher level requests that are coming through from data analysts who are much better at analysing data than we are as librarians. So it's then become more of a hand-holding. This is how you use the service. This is how you do it responsibly. And we tailor it. It's a one-to-one thing because every type of request is different. So trying to pitch it to we're trying to serve everyone when you get to this high level just doesn't seem to work. Our next steps is, because we've got this wider issue about prestige and metrics being used in the wrong way, we want to try and create an asynchronous resource that will be for anyone who might be touching metrics. So also in recruitment, like how to, if you're recruiting someone, how you should be using metrics, how you shouldn't is more of a thing. As a resource that's available to the wider university, we're going to try and make it as an open educational resource in Markdown so that we can then share it with people and they can build upon it. And of course, we're exploring all the new open source softwares and what kind of tooling we can use to try and do analysis. We are very beholden to the proprietary softwares, and we can't have all of them, even though we want them because of budgets. So that is my lightning talk. If that's our webpage, if anyone's got any questions about service delivery or anything like that, please do get in touch. We're happy to have our brains picked. Yeah.
Yeah. Thanks very much, Kate, for this talk. We have 5 minutes for any questions. Does anyone have any questions?
Really good work, Kate. So I used to previously work at university and had also taught bibliometrics, and I had found that, kind of as you described, some of the curriculum content that I was trying to teach in the sessions relating to the metrics, I sometimes found it really difficult to deliver in an engaging way, and found that actually sometimes the courses could become really driven by the experience of the attendees, so prompting them to discuss their own experiences and sort of these wider issues of open research and research culture. I wonder, is this something that you've found?
So we've certainly found with the staff course, they've got a very specific issue that relates to them, and then it becomes, we have to try and unpick it and go, we need to have this conversation elsewhere. The PGRs, they get very interested in being told that they don't have to do what they're being told by their supervisor, because their supervisor is following what is, you must publish in Nature, which is, if that's the right place, then yes. But if it's not the right place and a society journal is, then that's the right place. It's very different. We found in terms of different, we have a very broad, diverse research areas. It seems to be certain areas are more interested in that conversation than others. And often it's then come and speak to us, and we'll have a conversation with them one-to-one because they maybe don't want it on the recording and that kind of things. Sometimes we get tumbleweed and they were just there because they needed to tick a box. It also depends on what stage of their PhD they're at. Some of them who are nearer the end are far more interested because they've obviously decided they want to go into academia and be in this world and the research culture. And I think also maybe because research culture is such a big topic, they're seeing themselves as like, well, maybe if I'm a future leader, this is where I might be getting my insight, and I can be the different person here. I don't know, it's just the perception.
Yes, one question.
I wanted to ask: does your course is your course focused just on individual metrics? Age, index, journals, or newer responsible metrics, or does it also deal with broader issues such as information discovery or analysis of the research landscape in a certain field? Because, bibliometrics is often portrayed just as search for those indicators, whether they're good or not, but do we also talk about the broader picture?
So we describe what each of the types of metrics are. We describe the types of sources they can use. We discuss that different metrics fall in and out of favor. So obviously, like H-index was massive. We're now there's a trend against it because various reasons. Most of the course is focused on responsible use of metrics and ways in which you can do it be fair, which seems to be the concept they understand, the fairness. It's part of a wider landscape of research culture that is happening at the university, and we have a CHEP, which is I cannot remember this, higher education practice, Centre of Higher Education Practice, and this all kind of feeds into it. It totally depends on the user though, and the person who comes. We try, as we say, we're giving them the brilliant basics to say, like, this is where you can go, this is what you should be looking for or should avoid doing, and then come and speak to us if you've got something specific, and then we tailor it to whatever it is they're trying to do. So yeah, we're trying to give them the brilliant basics so that they can then do the go the right way.
It looks we don't have any online questions or comments. So if there is no other question, oh yes.
Thank you. Thank you so much for your presentation. Quite interesting. Resonate with me from my previous role as a bibliometrician at the University of Leeds and running the bibliometric service, which creating awareness about bibliometrics and the difference between bibliometrics and research metrics. So yeah, I totally resonate with your experience. And also bibliometrician and bibliometric practitioner, we are so enthusiastic that we create these reports and then overwhelm researchers because maybe they don't need that level of details. So yeah, so I wanted to ask you if any researcher come to your service asking, for example, about questionable journals or predatory publishing, or if they have received any. So what is the support that the bibliometric service offer to this kind of questions?
We've had one, and I'm drawing a blank as to what it is. It's on UK Core at the moment. Everyone's asking about it, where they've been asked to do something because they're a highly cited researcher, and then it's like, well, actually, it's very. I can't remember what the service is. It's very negatively viewed at the moment. We deal with it on a case-by-case basis. As I say, most of them, they're trying to do maybe a grant application and they need to identify their top 10. And it's like, okay, but what do you mean by that? And it's getting them to have that dialogue to say like, well, what explicitly have you been asked for? Because we could say your top 10 is your most highly cited papers, but that's obviously your newest paper isn't gonna feature in that, and that might be your best piece of research. So we deal with it on a case-by-case basis because there's such a variety of different grant things, different things people are trying to do, and it seems to be moving so quickly that we get something sorted in our head of that's what we're doing, and it's changed. So we do have to tailor it. It's not a one-size-fits-all. When you get beyond that, this is the base level. It would be nice if it was.
Thank you very much again for this great talk. And now we will have a lunch break. For our online audience, we will continue 1 hour later. Thanks very much, everyone.
for sure. I didn't know, I wonder what it meant to be. If I let go and let it flow, I think there's more to see. I just need a break. I'll take what you need. I just need to break. I'll take you to the trip to the other side. I'll take you to the trip to the other side. Take a sip, it's a trip to the other side. I'll take you to a trip to the other side. Take a trip to the other side. I'll take you to a trip to the other side. might agree. It's all for sure. You didn't know. I wonder what it meant to be. If I let go and let it flow, I think there's more to see. I just need a break. I'll take what you need. I just need to break. I'll take you to the trip to the other side. I'll take you to the trip to the other side. Take a step to the trip to the other side. I'll take you to a trip to the other side. Trip to the other side. I'll take you to a trip to the other side.
2, 3.
And then you go green. And you're on. Yeah.
Thank you very much. Can you all hear me okay? Is the mic working? It is? All right, terrific. And just to confirm how much time I have?
You have half an hour, so maybe try 25 minutes and then we've got some time for questions.
Perfect, yeah, exactly. That's what I thought, but it's the kind of thing you don't want to get wrong, especially after lunch when I know everyone's feeling a little sleepy. So yeah, my name is Jason Priem. I am from a company called OurResearch. We're the nonprofit that makes OpenAlex, as well as, I don't know, has anybody here, if you don't mind, raise your hand if you've heard of Unpaywall? All right, cool. Then yeah, we're the people behind Unpaywall as well, which is a little bit better known right now. So OpenAlex is, the name is inspired by the Library of Alexandria, which we know was a big project to try and collect all the world's knowledge into one place. And we're trying to do something very similar. And for this presentation, I'd like you to remember the word armlow, which means, of course, holding your arms wide on like this. But no, it doesn't really mean that, but it may help you remember the acronym. It's an acronym for All Research Metadata Linked and Open. So if you want to know what OpenAlex is armlow, which is all research metadata linked and open. So we're just going to talk about what that means. Split it into 3 parts: the all research metadata part, the linked, and the open. And I thought it would be kind of nice actually to do it in the form of a little table. So I'm just going to tell you exactly how the presentation is going to go, so there'll be no surprises, nothing up my sleeve, nothing up this sleeve. We're going to start talking by all research metadata. We'll say what are the problems with existing approaches to gathering all research metadata together. We're going to talk about what we do at OpenAlex and how that provides a solution to the problems. Then we'll do the same thing about linking research metadata, and finally about making research metadata open. And to finish up, we'll have a little dessert of three questions I get asked a lot about accuracy, stability, and sustainability, which is too long of a word to fit down there, so I said money, which is more directed to the point. We have a lot of euphemisms I think we use in scholarly communication, so we'll say money. Those are 3 questions I get asked a lot, so I'll finish up talking about those. So I'm not going to give a lot of talk about why research metadata is important, what we use research metadata for, because I assume the folks in this room are already relatively familiar with the answers to those questions. So we're going to jump straight into all research metadata. What are some of the people doing research metadata right now? We're talking about PID graphs, so like Scopus or Crossref, sorry, not Scopus, ORCID or Crossref, or Research Organization Registry, ROR. Those are some open places that are doing research metadata. There are commercial providers like Dimensions or Scopus or Web of Science. There are non-commercial providers like OpenAir. There's a lot of people in the research metadata game. And one of the problems that they all share is the problem of low coverage. That's the first thing we're going to talk about. A lot of folks, when they're doing analyses of whatever they're using research metadata to analyze, they find that, gosh, it would be nice if I could see data sets in this. It would be nice if I could see software in this. It would be nice if I could see books in this research metadata data set. And so a lot of products are not represented in traditional research metadata graphs. Moreover, a lot of regions are not represented. So for instance, I might say, well, gosh, I would love to see representation of countries in the global south in my data set. But unfortunately, a lot of those countries are very underrepresented in traditional data sets. And finally, another problem you might have is, along with the region, and what was the first one I just said, the product type, is you might have just the overall scope, how many things are actually being fetched, particularly from different sources that maybe are not very well represented in traditional data sets, like maybe journals that are not up to the quality standards of the traditional data sets. A lot of times people are interested in what's in those journals, what's in those sources. So I want to talk a little bit about how we get metadata, and then I'll talk about how that solves that problem. So the big thing with OpenAlex is we set out from the very beginning to be a comprehensive data set. So the reason I always lead with that Open Library of Alexandria comparison is because they were really trying to get everything in the world. That was the idea. It was a universal data set, right? And that's what we're trying to do too. We're trying to get everything there is in the world. If it fits into the category of research data, we're trying to bring it in. How do we do that? Well, we have 4 main sources to do it. I mentioned PID graphs before. I'm not going to hit you with a list of all of those. We can talk about them in the questions. If it is a PID graph, we're probably gathering data from that. So the big ones are ORCID, ROR, Crossref. Arguably, the ISSN Foundation is a PID graph. These are pretty well established. Most people know about them. We're also doing harvesting directly from the web. So same as Google or somebody else like that, right? We're like pulling in web pages from a lot of different providers. We're harvesting from repositories. So those are institutional repositories. Places like, the University of Brighton, I'm sure, has an institutional repository. Anybody know what that's called? Pure. Great. So the Pure repository at the University of Brighton. We harvest many thousands of institutional repositories. And then finally, also disciplinary repositories. So those would be places like bioRxiv or arXiv, original recipe. And then finally, open services. So DOAJ would be an example of an open service, right? Directive Open Access Journals. The Open APC project would be another example of an open service. So they have some kind of open data set that they use. And we cover quite a large number of those. So the result of this is when we start with the problem of low coverage, we're adding a really wide variety of data sources. It ends up with capacious coverage. And specifically, as we mentioned before, work that represents these kind of 3 areas. The work type, so we have good coverage of data sets. We have about on the order of 10 million data sets in OpenAlex. We have good coverage of books. We have something around 7 million. We have good coverage of dissertations. I think we have 4-ish million. There's quite a lot of coverage from often neglected types of work. We've also got, that's in the middle, we've also got coverage of domains, which I forgot to mention earlier. So for instance, social science, we've got about 66 million social science papers or works in OpenAlex, which is higher than a lot of the other data sets. And then finally, region I mentioned. So a lot of times we have works that are underrepresented, works from countries that are underrepresented in other data sets, because a lot of the countries are publishing in languages other than English, and a lot of those countries are publishing in venues that don't meet I use the air quotes, kind of quality benchmark of traditional data sets. And the reason I put that in air quotes is I think quality sort of depends on what use you have in mind, right? I think instead of the idea of saying, well, there's one threshold for quality and everything above it is sufficient quality and everything above it is below it is insufficient quality, seems a bit, I don't say naive, because maybe it made a lot of sense in the world of paper and file folders and stuff where a lot of the traditional data sets developed. But I think it doesn't make as much sense today in the electronic world where we can kind of change the threshold depending on what question we're asking. So I know this is a group that enjoys numbers, so I want to throw a couple numbers at you here. These slides, I will put them online afterwards if someone reminds me, and you can peruse those at your leisure. But the important takeaway that if you just kind of look down there scanning is you'll see that compared to a lot of legacy data sets, OpenAlex really is all research metadata. Now, we're not quite there yet. There's certainly a lot of research metadata that we're still looking for. And we'll talk a little bit more about the progress that we're planning to make over the next few years. But even now, you can see that we're really that we really just have a much broader understanding of what counts as research metadata, and therefore we have a much bigger data set. I'm a visual guy, so I always think a picture is nice here. This is from research that was done not by us, which is always nice, and you can go visit that on arXiv to get more data. But you can see from that Venn diagram, right, that Scopus and Web of Science, they are covering a lot of the same sorts of stuff, and we are covering pretty much everything they're covering, plus a big old universe of other stuff that they just sort of ignore. And so that's why I like to emphasize that all research metadata, because that really is a big focus for us. So I said it was all ARMLA, right? So all research metadata, linked and open. So we're going to go to the linked now. So what is the problem when it comes to linking research metadata that I think needs to be addressed? Well, I think the problem that needs to be addressed is lock-in. And when I say lock-in, I'm specifically talking about the commercial vendors, which are, as we know, kind of dominating the market. And I don't think that necessarily the commercial toll access business model is an evil one. I just think it's an outdated one. I think it's an approach to generating revenue that has sort of outlived its usefulness. And one of the reasons why it has is this problem of lock-in, is that, kind of once you get started with one of these systems, it's very hard to move to a different system, right? You kind of get hooked on that one particular system, that one particular approach, and since you can't easily hop back and forth, you're kind of stuck. You're kind of locked in. I can think of two ways that lock-in really sinks its teeth in. One of them is, of course, the money. Once you've spent a lot of money on a particular system, it's really expensive, so you spend a lot of money on the rest of the stuff on campus to try and train everybody to use a system, try and publicize the system, right? It just becomes kind of too big to fail at some point, right? You're just like, yeah, I can't get rid of this. We've spent so much money and credibility and time and everything else on it. The other part of it is a little bit more subtle, and I think it's maybe even more important, though, and that's the curation cost that gets sunk into these systems. So all research metadata is wrong at some point, right? Every data set has got errors in it. And what ends up happening for most institutions is they put a fair amount of effort and time into curating the accuracy of whatever metadata provider they're using. So if they're using Scopus, for instance, they spend a lot of time doing Scopus searches and trying to figure, oh, it's wrong here. Let me submit a change request to my Scopus people, and they'll fix it. And there's this big chain. It takes a long time. But the nice thing is, typically, from people I've talked to, folks at Scopus, Web of Science, Dimensions, the commercial ones, they're pretty good about you submit these corrections. Eventually, it takes a while, but it works the way through the pipeline, and the data gets better, which is nice. But that's all work and labor that you as at the library or whoever at the institution is responsible for this, all of that labor, or as a researcher, all that labor goes into making those data sets better, but it's all locked in, it all stays there. They get better and they stay better, but the rest of the world doesn't see that. So we've got everybody in these kind of vertical silos trying to make their own improvements on other people's data sets. So here's how we handle that idea of linking, right? We're still talking about linked metadata. So we do this in a very open way, which is very different from how, like I said, kind of legacy tools do it. We have sort of two sides to it. One side of it is AI. I have to say AI, because otherwise you guys can't check AI for your bingo card today. We're not allowed to do a presentation without saying AI anymore. That's a rule that I understand was passed in about 18 months ago. So we have to use AI, and that basically is the stuff that deduplication. So, my name is Jason Priem. There's another guy named Jason R. Priem, and he's publishing some stuff. Are we the same people? That stuff's not that interesting or exciting to me, but it is extremely time-consuming and expensive, as we know. So we've trained algorithms to do that and everything. Name disambiguation, preprint, connecting preprints to papers. That's another big one. Disambiguating two papers. We got one from Pure at Brighton. We got one from Crossref. Are these really the same paper or are they not? We got to connect those. So we do all that stuff. But then we have the manual side of it, which I'm interested in because, as I said, there's like untold money being spent by libraries, researchers, lots of other people doing manual curation on legacy data sets. So we've got three sources that we get manual curation. We get stuff from funders. We were working on a couple pilots. It's really interesting from funders like the, I can never remember their name because it's in Dutch, but the Dutch national research funders. The Austrians and their national research funders, folks in Canada, the Danish, A lot of European national funders are working with us. And we're in early stages, but we're starting to get funding data from them, which is really cool because we can use that to enrich our funder data. We get data from institutions. We get a lot of data from institutions because, as I mentioned, the institutions, they're doing their kind of data curation stuff, and they find problems and they send it to us. And then we get a lot of data from, I was mentioning these PID graphs, so from ORCID. So when someone goes, and the cool thing is, when I say this is manual, it's manual because if I, as an ORCID owner, my name is Jason Priem, I have an ORCID, blah, 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 I go to my ORCID and I fix something. I'm like, oh, my ORCID is wrong. Let me fix this up. That goes into OpenAlex, right? Same thing if a great one is ROAR. ROAR is a terrific initiative. I absolutely adore what they're doing, right? It's a unique identifier for every institution. And as an institution, if I see something wrong with ROAR, and people do all the time, you go into ROAR, you make that little change, and boom, it shows up in OpenAlex, right? This way, all that manual work that gets done actually stays with the community, right? It doesn't just go into some silo where it then gets sold back to the community. And so that is why that's kind of the solution, is I would say the solution is community. So if we look again at that issue of linking, then the problem is lock-in. The way we do it is a combination of automated and manual, and that solution is about community. And I wanted to show you one cool example of a community project that I think exemplifies this path, and that is from the French Ministry of Education, and it's called Works Magnet. And you can go check this out right now. I don't think there's a link on there, but you can just Google it. And this is a tool that was built by them. It's an open source tool, and it allows you to do curation on the OpenAlex data set using their website, using their tool. It's pretty cool. So I have an example here where I searched for MTSU. So MTSU is Middle Tennessee State University, who I love just because I think they have an amazing name. And if you are Middle Tennessee State University and you're like, oh, is the acronym MTSU really being captured? Like, are they doing a good job when they detect that in affiliation statements and metadata of attributing it to us as it should be attributed to us? Well, let's check. So you can do a little search for MTSU and you can see these affiliation statements, and then you can tick them and provide these manual curation packets that go back to OpenAlex, and then we can improve the data set. This, I think, is a great example of how community can be providing an antidote to lock-in. This is the exact antithesis of lock-in. This is everybody working together to improve something that we can all share. And then finally, I said I would talk about open, right? So we got all research metadata linked, we already covered that, and finally open. And of course, the problem with open is that a lot of legacy metadata providers ain't. They're not open. And so there are limits on use. And specifically, I think there are three main types of limits that are really smart. I think number one, it's very difficult to export the data from those tools. They're closed tools, right? So their mentality is, how do we keep the data with us? How do we protect the data? How do we put walls around the data so we can sell it? That's their mentality. So if you want to export, let's say, a data set of 10 million items to do some research on, it's kind of like pulling teeth. It's not that much fun. So export is a big issue. If you want to build stuff on top of those data sets, that's an even bigger issue. So let's say I want to make a dashboard that, that shows for my institution my international collaborations. And I want to use data from Scopus or Web of Science or Dimensions. I don't want to pick anybody in particular. But if any of these closed systems, again, it's almost impossible, not 100% impossible. It's really challenging to try and repurpose that data into a dashboard that you can share with the rest of the world. And that's because that sort of antiquated business model of we're trying to enclose data, trying to put walls around it. And then finally, transparency. You know, this is one that is a little bit less tangible, but I find that it's very significant for folks, is people are increasingly relying on these tools to do real-world evaluations that have real stakes. And people really do not like the idea of real-world evaluations that have real stakes based on shadowy, undisclosed figures from somewhere, right? And that's another reason errors are you can't really use the data. You can't say, hey, I made some decisions based on this data. Now let me use that data to back my decisions up. No, you can't. You say, I made some decisions on the data. You just have to kind of trust me. Like, it's good data. We paid $100,000 for it, so it must be good, right? So here's how we do it. Here's how we provide the antidote for that. We're open in a lot of different dimensions. So let me talk first about kind of in the broad sense, and then I'll zoom in. So all of our data is open. I'll talk a little bit more about what that means in the next slide. It's all shared under, so you can get it. We'll talk more what that means. It's shared under an open license. Technically, it's not a license. It's a CC0 public domain declaration. So basically, it's irrevocable, that data is in the public domain. It doesn't belong to us. It doesn't belong to you. It doesn't belong to anybody. So it's legally right as open as we can make it. All of our code is open. It's licensed in our MIT license. You can find it all on GitHub. You can download it all. Many people have. It's shared on Software Heritage. So it's archived. If we just go away or we decide we want to become evil, that code is going to be still open in the public eye for as long as the institutions doing that can maintain their persistence. And finally, our organization itself, as I mentioned before, is a nonprofit. We're a very transparent organization. If you want to see how much I get paid, you want to see how much we spend, you want to see our revenue, all this stuff, you can just go look that up. We put it all on our website. So when I mentioned the openness of the data, there's three main ways that we make the data open. The first is a data set that you can download. This is basically the equivalent of driving a big truck up here full of extremely valuable minerals, diamonds, I don't know, and dumping it on your lawn and say, hey, enjoy, here it is, right? It's very large, it's very valuable, it's very cool, but it's a little bit unwieldy. It's about a 500 gigabyte compressed file. But you can do that. You can have every single datum that we possess at OpenAlex very easily. Again, it's a little bit of a pain to work with. We also have an API. So you just call our API endpoint, you get answers to your questions. That's the way a lot of people in Bibliometrics use it. And then finally, we've got a website. I want to show you a couple examples of, this is of course an open and free website, some questions people might ask on this website. So this question is, I can't quite read it here, let's see who in the UK is working on gender equity in medicine and is getting reasonably well cited for their work, more than 10 citations. So we just run that query. The cool thing is you can export this as an API query as well. So everything you see in the UI can easily become the basis for a dashboard or for a research project. Here's a second one. This is show me all of the, what does it say? All the open access, all the APC costs that the University of Brighton is incurring since 2021. And this is, again, using that open APC data set as well as some other APC data sources. A lot of people find this valuable for negotiation purposes. And then finally, this one is show me all of the collaborations that we're doing at the University of Brighton with people who are at institutions in the Global South where their citation percentile for that year is in the 90th percentile. So in other words, things that are adjusted for year, high impact, high citation impact, that are collaborations with folks in the Global South. And you can just see the works. Of course, you can download all this straight off the website if you want. You can download quite a lot of stuff from us. So what we see then is that that's how kind of we make all of our data open, how we're trying to solve that openness problem. And the result of that is creativity. And I want to give you a couple examples of creativity. This is VOSviewer, which I think many people here, how many people know about VOSviewer? Sweet, everybody knows, that's awesome. So you can use VOSviewer with OpenAlex data. All you got to do is take our URL, post it in VOSviewer, and boom, you get open, reproducible networks of collaboration or whatever else you're trying to visualize. This is the University of Washington. I mentioned dashboards. This is a dashboard they made about who is collaborating with researchers from the University of Washington. This is all built on open data from OpenAlex. And it stays updates. It's a live thing that they can show on their website. So it's another example of creativity. And then this one I just saw today. Thank you from Angela, thank you. I wasn't sure the pronunciation. From Angela in the front row. This is a project that he's doing with OpenAlex. It's called, do you pronounce it AIDA? AIDA dashboard, excellent. And you get a sense of what that is. I just learned about it this morning, which I think is pretty cool. I'm always running into people who are doing cool new things with OpenAlex. Did you want to say a word or two about that?
Yeah, John, we support users and as well as editors, as well as conference organizers in analyzing conferences. We use OpenAlex data. We map it with other information like industrial sectors for affiliations that come from the industry, just to understand a little bit more who are the customer of a particular conference. And sorry for using customer.
No problem. So we see that if we have the problem of low coverage, OpenAlex solves that with capacious coverage. With the problem of lock-in, we solve that with community. And with the problem of limited use, we solve that with creativity. So we've got all the L's for, we'll say, maybe losing approaches, and all the C's for, we'll say, for cheerful approaches, even though it doesn't sound like a C. A couple quick words about accuracy, because people often ask that question. I can get into more of this if we have time in questions. But we can see a lot of studies that people have done that show very tight clustering with traditional data sources, just more. We just have more stuff, but the stuff where we compare like to like, it's very similar. This is the open latent ranking done out of CWTS, which is pretty cool. I get a lot of questions about stability. We've been doing this for a long time, actually. So we are, OurResearch, the company, is more than 10 years old. We're used by pretty much everybody you can think of, especially on paywall. We're used by Clarivate and OCLC and Elsevier and kind of the who's who of scholarly communication. We serve about, since I've been talking, we've served many tens of thousands. We serve about 200 API calls every second for Unpaywall and about another 100 every second for OpenAlex. So it's very heavily used, and that's been true for many years. So I think it's a pretty stable system. We're talking about sustainability. We do have a premium plan, so everything we talked about is free. We're very much on terms of everything being free, but we also say that even though the data is free, our time and our servers aren't. So we charge for services, not for data. We have a premium offering. If people are interested, they can check it out. It basically allows, at the institution level, the institution you get training and priority support as well as elevated API access. That's working pretty well. You can see these as our annual recurring revenue for OpenAlex, which is going up and to the right, which is what you always like to see. We also have got a 5-year grant from the Arcadia Fund, which is a funder here in the UK, for $7.5 million. So between those two things, and Unpaywall has been sustainable for 7 years now or something like on earned income. So it's a model we know how to do. I just wanted to quick close by this Barcelona Declaration of Open Research Information. Anybody seen this before? A few? Okay, cool, yeah. It's a great idea. It's the idea is saying, hey, we want to, as people who use data, only use open data. So I love that. We say that we want a community. We say we want to do this together as a community, openly, in a not locked in way. So I think let's do it. OpenAlex is a good way to do that. Any questions? Oh, thank you.
Thanks, Jason. That was really interesting. I was interested in your use of, the capability of users to modify, update, correct data. Do you have a capacity for data triangulation in any way to kind of check the veracity of some of those modifications that people might be suggesting?
Yeah. I mean, we definitely monitor everything, if that's what you mean, yeah. Yeah, it's pretty straightforward. I mean, like, most of the corrections that we would get, if they're quite easy, just anybody with a brain would be able to look at them and say, oh, this is bogus, or this is legit. There probably are some edge cases that are really hard to figure out or something like that, but I would say 99.9% of the corrections we get are pretty much extremely apparent that we made a big mistake, and the correction is quite straightforward. That's a good question, and yeah, but the moderation component is pretty important.
Sorry, I'm just trying to figure out how to phrase this. Do you have a sense of where the metadata gaps still are? So, like, classes of publications where you have the publication data, but you don't necessarily have the affiliation data associated, that sort of thing.
Classes of information?
Like,
okay, like where the gaps
this
in OpenAlex.
cohort of papers is better than others, that sort of thing.
In OpenAlex, where are the gaps? Oh, for sure. Yeah, I think about that every day. So yeah, I have probably as good a sense as anybody. Our grant information is still quite sketchy. I would say we definitely need a lot of work on that. That's why it's pretty cool that we're working directly with the funders, because they often have good information. That's a big one. I would love to have better coverage of software than we do. Our book coverage is, I think, industry leading, but still has a long way to go. Books are kind of notoriously hard. Yeah, I guess those are the big ones that jump to mind right away. I think our affiliation coverage is also probably a little, so for a given university, we generally get more affiliations than, say, Scopus or Web of Science, but that's just because we have more stuff. We are, as a percentage of the papers we should be getting affiliations for, we're lower than they are. It's just that we kind of solve it on volume. So that's kind of one of our challenges, is just continue to get better and better. And working with the institutions is really helpful for that. And I could talk for an hour on all this stuff. I wish we were doing better. So that's a good question, and I hope I won't bore everybody by getting into too much detail about it.
This probably follows on from the earlier questions, but what about when it comes to historical data and coverage? So Web of Science and Scopus sort of go back to the early 1900s or even in the 1800s. So what is the coverage there, or what are potential gaps or issues with sort of more historical data?
I would say we're comparable to those other systems. I don't think we have a weakness in historical data. I think the whole world has a weakness in some kinds of historical data that hasn't been digitized yet, or is sitting in a dusty archive somewhere and, hasn't really entered the world's metadata consciousness. But if it has, I think we're pretty good at it. We inherited a lot of data from Microsoft Academic Graph, which was quite good at that. So I would say, yeah, I don't view us as having any weaknesses in terms of historical data, other than, like I said, the kind of long lost Indiana Jones type stuff that everybody has a weakness on.
Could you comment on the difference between your data set and the Google Scholar data set?
Yeah,
because
great.
the Google Scholar has a similar mission to capture all openly available research data in the world.
Yeah, I would say that for me, the mission is a little different, actually, because to me, when I look at, and I would have to, I've talked to Anurag briefly, but they seem to be quite focused on, I would say there's two major differences. One of them is they're quite focused on discovery of research papers. So it's very similar to Google, right? Like I want to find out the best pizza place in town. I want to find out the best paper about altmetrics published in the last 10 years or whatever. So they're really focused on discovery for a research paper. OpenAlex can be used for that, but it is not nearly as much of a focus for us. We're much more interested in analytics, in knowledge discovery, in kind of broader usage of the research graph. I always kind of make the comparison of OpenAlex, I want it to be the pipes underneath the city, like the city of Brighton, for instance, that bring the water to everywhere, to the universities, to the restaurants, to the hotels. Everybody can build stuff on that set of pipes, on that network. I want to be that network. I think Google Scholar is a little bit more of a service that they built a thing, and they built a big well, and they're handing out water to anybody who comes around. So I think it's a really good thing. I use Google Scholar a lot. I like Google Scholar. But it's not really built for reuse, and it's not really built to support other people's tools. It's really built to solve one use case for one researcher at one time. And so that's why they, for instance, don't cover, institutions. They don't have, institutions aren't part of their graph, for instance, because it's not what they're focused on. But I would say their coverage is spectacular. Good for them on that. And if they ever want to make that open, we will add all of their data to OpenAlex.
Hi. I'm a user of OpenAlex. I use it every day, me and my team. And we were users of Microsoft Academic before. So you've shown the money part. Great, thanks, and hope you continue that way. But just wanted to have your view on, in the future, once your 5-year grant it's over, are you going to maintain the same mode? Do you think of maintaining the same mode, or will you need to rely more on the premium access? Could you give us some ease of thought so that we don't get all nervous and in panic again when it happened with Microsoft Academic?
Yeah, well, I mean, everything's a risk, right? I mean, Scopus can go out of business, Web of Science can go, anybody can go out of business. There's no guarantees in this world. But I will say that we've been making Unpaywall a completely open service that is also supported by premium subscriptions for, like I said, about 7 years now. We know how to do that. I think that we're pretty good at it, just judged on the track record. So I like our track record for this. You can look at our grant. It's online that we submitted to Arcadia. And it shows how, our Arcadia draw goes down every year and our revenue goes up every year. Predictions are cheap. I can show you that line. It goes up on the right. That looks pretty good. I can say we've got experience at it. That looks pretty good. And the last thing I'll say, so to me, that looks good, but I'm a founder. I have to be like a little bit in the reality distortion field. So I think you just got to make your own judgment based on, our performance to date. But I will say this, and I think it's really, really important. Whoa, sorry. And that's that, if you, any metadata graph that you start using, you're kind of getting in an airplane and just hoping that the pilot knows what they're doing. But if it's an open metadata graph, you've got a parachute, right? And that parachute is if everything goes south, if it all collapses, all that data is open forever. It can't be taken back. It's public domain, right? All that code is open. And so if you got to start doing your own thing, God forbid, you've actually got 95% of the way there already, just using stuff that we've done that's in the open that can't be taken back. And that's what I think is so important. That's where I think as a community, I think we've been a little bit too lax on data providers saying, oh, we'll just trust you. We assume you'll be around forever. Thank you. But what if they're not? What if they change? And that's where I think we need to start being more insist on doing things as a community and say, there has to be a fallback. There has to be like a plan in place for if you go away. So to me, in a lot of ways, OpenAlex is kind of the safer option because at least if we go away, you've got a parachute.
We've got a question from the online community here.
So we have one question, which is short. Do you harvest data site metadata?
Yes.
That was quick. We've also got a comment from the online people that they didn't hear Angelo when he was talking about AIDA. Would you mind repeating what you said?
Oh, really?
Yeah.
I can. Simply put, it's just a dashboard that allows users to analyze venues, journals, and conferences. And typically, it's designed also for conference organizers to understand a little bit more who are their attendees, whether they come from the industry, and if they do, which kind of industrial sector, and also which kind of institutions and so on.
Thank you so much. I think, yes, we're out of time. So thank you ever so much again, Jason. And that all sounded amazing.
Thank you all very much.
Sidewalk behind you and get the next slides up. I think I've got it. Is it the Clarivate next?
Yes, Clarivate, but he sent an update.
Oh, a new version. Blow. Okay, sorry about that, just teching ourselves out. So now we have Ryan Beardsley from Clarivate, who's going to be talking to us about patents and impact.
Is that better? Can you hear me now? Is that working?
I think so.
Yep, okay.
Sound done? Yeah, that's all good. Thank you. So, Ryan Beardsley.
Thank you very much. Well, thank you for coming and listening about the science behind technology and beyond. So the presentation today is going to be split between two authors. I'm Ryan, obviously, and Mischo is here from the ISI, and he's going to take the end of it. So he's going to be doing the and beyond bit, and I'm going to be doing about the science underlying technologies. So I am a consultant in the academic and government consulting practice in Clarivate. We're a team of about 30 plus consultants spread all over the world. We all work collaboratively on projects so that we get a kind of a global view of the things that are going on. Our customers generally are all the usual suspects, funders, institutions, government ministries, some large multinational corporations that have a small research footprint, perhaps, who have maybe slightly different questions to others. So I think this issue of impact is coming up a lot with our customers in different guises. And to try and think, I'm not going to make the argument that our data is a direct proxy for the healthcare impact or growth in GDP or something like that. But I think that Clarivate have a lot of data. I have the data sources here. And to point ourselves in the direction of impact is just like the first step along the vector in the direction of impact. We have all of these data sources. Obviously, I'm more of an expert in the Web of Science side. And as you go across this to the right of the screen, I get less knowledgeable. But I think there's definitely, it's clear there's a lot of opportunity for us to be able to say things about areas that are based on science as well as science itself. So it's going to be interesting understanding how we're connecting these data sources together. Today, I'm going to talk about the patents data. So you can see we've got Web of Science on the left there and Derwent, which is the patent data, but we have these grants. One thing that's interesting to me, at least at the moment, is the news that we have through the ProQuest data. So we have all of these news articles, sometimes going back to like the 1890 or something. So I think that's potentially quite rich for us. As well as all these data sources, we have, this is a very marketing-focused slide. You can see all of the various metadata things that we've got in there. Some of these are related to clinical trials, drug pipelines and things, and obviously some of them are related to bibliometrics and Web of Science. Underneath that, there are the tools and the services that we provide. I promised my colleagues that I would mention the Research Horizon Navigator, which is a new tool that we've just released as part of Insights, which is for surfacing emerging topics. So highly cited emerging topics. It's got these graphical elements and you can search your way around. Unfortunately, I don't really have time to talk about it today, but my colleagues are very knowledgeable about it, way more knowledgeable than I am. So please talk to people if you're interested in emerging topics. So I mentioned that I was going to talk about the IP data and how we're connecting that to Web of Science. I thought I'd just put these numbers up there to illustrate that the similarities, or like how parallel these databases run. So on the left, we've got Web of Science, which is kind of used to describe the database, but also the search and discovery tool that sits on top of that. And then our analytics tool, which is Insights, which aggregates and analyzes the data. In DWPI, they have the database, which is the Derwent World Patent Index. They have a tool sat on top of that, Derwent Innovation, which is kind of an amalgamation of the Web of Science, Search and Discovery, and Insights. It's like a kind of combination of both of those things. So, and there's obviously a lot of IP documents in DWPI. You can see the numbers there. So the question is, when we have customers come to us and they're interested in these different facets of the technologies that they're developing perhaps, or the science that they're doing, how do we analyze those and be able to provide enough information for them to make the decisions that they need to? Traditionally, we've done that through search queries. You know, I think many people are familiar with the search strings you put into Web of Science, you pull the documents. You have the same techniques available to you in DWPI, and you can pull out those documents through Derwent and create kind of a parallel analysis. You can do many of the things that you can do that we do in Web of Science in Derwent, and you can have these parallel studies, and we've done that many times for customers. That's really useful and very valid for many use cases, but there's more. Obviously, we have citations which come from the patent documents into Web of Science. And the question is, how well does the search string methodology correlate with the citations? So just to orient you on this slide, the left-hand side is like a global landscape of Web of Science. All of the little gray dots are journals just purely put there to create the space. The little flags you can see are the ESI categories, which are the 22 categories that Web of Science used to break up the research. The purple dots on that map are just as a vehicle to help us discuss this are AI applications. So each dot you see is a publication is some application of AI in the research landscape. On the right-hand side, you have the count of the documents. You can see over the years that's obviously normalized. The scales are different. The counts over the years increased quite rapidly around 2018. That's particularly true for the patent documents because, like I say, they're scaled differently. The blue line there just indicates what year we're on, obviously. And then at the top on the box is talking about the citations. So the question is, if we develop a search string in Derwent and a search string in Web of Science, do the citations land in the Web of Science topic that we kind of, the sister topic? And it turns out that in 2013, that's not the case. So these search strings were developed by AI domain area experts, so I don't think we could reasonably expect to do much better than where we are with those topics. Yet the citations are missing the Web of Science topic. And I guess if you think about that, it's not so surprising because the technology and the science are not the same thing. And if you develop search strings, it's very difficult to develop a search string for the science that underlies a technology. But as we go through this over the years, you can see that on the left-hand side of the screen, the AI applications are kind of fizzling around on the map there. By the time we get to sort of 2018, 2019, things are starting to become a bit more interdisciplinary, or at least that AI is getting applied elsewhere on that map. At the same time, the IP documents are really starting to take off, still missing the citations in the Web of Science topic. And by the time we get to 2022, this map obviously is full of AI. So you've got computer science as the big blob down on the bottom right. You've got molecular biology kind of in the middle, clinical medicine at the top, and then linguistics at the right-hand side of that map. And you can see if you go back to sort of 2018, there's a bit less on the right-hand side there, where the LLMs are coming in and doing all the stuff in the social sciences and linguistics. So that's interesting. So when I looked at this, I was thinking to myself about why it is that we're missing the citations in the Web of Science topic. And maybe it's because this map is so full of all this AI that those citations can just land anywhere. You know, they've got all kinds of things that they can look at. So I tried a different topic, magnetic tape storage, which I think is very much more specific than AI, much more localized in on the landscape of Web of Science. And you can see that I've got some numbers here, plots about the numbers of publications. So you can see that there are very few, relatively, publications on magnetic tape storage in Web of Science compared to the number of IP documents. I think that makes sense. This is a technology, right? This plot on the right-hand side is the citations. Almost all of the citations, I think there are just a handful that go from the IP into the topic that we're expecting. So the obvious question then is, if they're missing the topic that we've developed, the search string that developed, where are they going? So I took those citations and expanded them out using the network, using co-citing documents and looking at the similarity, checking similarities, ensuring that everything is kind of self-consistent and related, and did a little bit of clustering and pulled out these different topics. And I think what you can see here is that you can see the different areas of science that feed into that technology. So obviously in the bottom left, we've got underlying physics. So these are things about magnetism and the magnets on the tape. Magnetoresistance, there was a Nobel Prize for that in 2007, I think it was, or some early in the 2000s. So this is all about physics that underlies the magnets. Then you've got hardware integration. So how do we turn those magnets into voltages that our computers can read? That's one aspect of it. And then you've got technologies down here. So some of these are related and some of those are synergistic. So for example, smartphone sensors use very similar technology to tape recording. And then things in red, which I think have erroneously found their way into this IP search string that we did, and then shown themselves in Web of Science after we have made this citation transition across. So the fingerprint one, for example, that's about people dusting for fingerprints. They use magnetic particles. They stick a tape on those particles, and then they use that to store the fingerprints. So it's got all the same keywords. So using this technique, and by doing this clustering, we can kind of identify those things, especially if you have some expertise in that area as well, which many of our customers do. So they will have access to domain experts. Maybe they're funders who have a set of researchers that they work with in order to help them develop strategies, or maybe they're institutions that have academics that they can work with. So they can identify those pretty quickly and chop them out of this discussion or that decision-making process, and then they can kind of look at these topics individually and see, make the decisions that they need to make. And that might be about impact, it might be about investment in a particular technology area, particularly in corporate, for example, that are looking for people to collaborate with, or something like this. So in conclusion, I think the point really is maybe the original conclusion of bibliometrics, which is that indexing citations is really useful. Language and citations aren't the same thing. They encode different things, and using both of these methods can give you different perspectives on these two databases. I think if you use search strings, you can look how technologies are expressed in Web of Science, and if you use citations, you can find the science that underlie those things. I think that's a fairly unsurprising conclusion, but it's very useful to our customers to be able to do these kinds of things. I think often it's the case that we'll probably run both of these things in parallel and offer these different facets that they can use to help make their decisions. So with that, I will end, and I'll hand over to Dimitro to say his piece, and then maybe we can have questions at the end.
Thanks so much, Ryan.
Yeah, no problem.
Firstly, nice to meet all of you in person. My name is Mischo. I'm leading the team of the Institute for Scientific Information at Clarivate, which is the R&D arm of our Research and Analytics division. And I'd like to announce something exciting that is coming very soon, and to make a bridge between that and what Ryan presented. Just a question: what's about other types of impact beyond technology? Societal needs are diverse, as all we know, and all funders, including institutional management, they are looking at competing priorities, what to fund with limited R&D resources. So what they should invest into the impact in technology, or into the impact of in medicine, or into the impact of environment, or legal, or political facet of our society. Also, no universal metrics or evaluation methods exist for every single societal need, and that's why that's a challenge to build something for evaluation of impact in the technology versus evaluation of impact in legal, for example, and governance. Another big problem or challenge with evaluating broader societal impact of research is already mentioned before by some other speakers, the time lag of research, which is about time that it takes for research to have impact on societies. Sometimes it can be even 10, 20 years, which is very often the case for fundamental research. So how to not only acknowledge this fact, but to take it into account in the evaluation of research impact, and how to meet together already observable impact with impact that can be or maybe potentially be observable in the nearest future, or within certain time lag. And another big issue is to meet well-established quantitative metrics or quantitative techniques or measures, especially traditional centimetric approaches, with so-called qualitative methods represented by use case analysis and textual information analysis, surveys, etc. As we know, traditional centimetric is established, it's scalable and objective, but at the same time, usage of, let's say, use cases analysis or case studies analysis, it's quite adjustable in terms of what we want to evaluate, so impact into what, but at the same time, it's quite not scalable on the global scale, right? So we can do that even on a national level quite often, and that is the case in many examples in the UK and around the globe. But to scale this exercise and to evaluate case studies on impact stories on a global scale, it's a challenge. So the Institute for Scientific Information has prepared the first report in a series of our response to these challenges, a report on a responsible framework for evaluating the societal impact of research, which is coming soon, tentatively end of September. By this link, you can register for downloading this report, and also you will receive a webinar link supporting the explanation of this. We welcome any feedback, so once you get that and you have any ideas or feedback, please reach out to us. We welcome any market feedback from researchers and evaluators around the globe to understand what we can do better to serve the needs. this will also result in a implementation of best practices of this framework in our products, which is coming also soon. So yeah, please let's be in touch and welcome. We welcome any feedback in future. Thank you.
Do we have any questions for Dimitra or for Ryan? Anybody? I'm probably just missing people. No. Oh yes, sorry, right in front of me.
I'm interested in the societal impact of research. I guess one of the interesting things about fundamental research is often the impacts are unpredictable and outside of, you know, the research might have been done for a particular purpose and yet its impacts are somewhere else. Is that something that's easily captured?
I'm not sure if you hear me on the internet, right? Probably yes. Yeah. Right. Cool. Thank you. Yeah. So absolutely true. This is what we already observe with our numerical experiments when a research done, for example, in medical area has a great impact on technology or on legal area, meaning where we didn't even expect to have that impact. So, for example, implementation in some policy or guidelines or even legal national documents. So, yes, this spillover effect of how we call this, many people call this the same, is something that is already visible in, and to be honest, it will be presented in that report that I'm referring to. So, yeah, quite an interesting observation. Thank you.
Any further questions? Yusuf, do we have anything from the internet?
No.
No. Okay, in which case, thank you both very, very much.
Thank you, everyone.
Okay, do we have... Okay, so now we have Euan from Overton, who's going to talk about how you can use the policy database to map your academics to government priorities. Thank you. The word just went from my brain.
Hi everyone, nice to be here. Everything's showing right. Yeah. Let me start this. Yep. So my name's Euan. I'm from Overton. I wasn't going to do a talk about Overton. Actually, I was going to talk about some of the things we do and then generalize it to how you could do it as well. Just to kind of look under the hood a bit and to show that some of the stuff we do, I probably shouldn't say this, but some of the stuff we do isn't actually rocket science, right? You can replicate it at home. We hope that we can do it at scale and in a way that, you know, is a bit cleaner and easier for you. But yeah, just wanted to show what's possible actually with kind of currently available APIs and open data. It's quite good that I'm talking after Jason actually, because we also use OpenAlex a lot for a lot of the stuff we do, and actually I'm going to talk about using it in this presentation as well. Okay, so first of all, just to kind of lay some groundwork. You know, the title of the presentation was Better Living Through Bibliometrics. That's because at Overton, you know, really what we're interested in is this, better living through better policy. And especially you hear sometimes this phrase, evidence-led policy or evidence-informed policy is what we say nowadays, where the idea is that when governments make a decision, when policymakers make a decision, it should be backed up by expertise and evidence, and at least some of that should be coming from academia, hopefully quite a lot of it. And you know, where it's coming from is governments want the best possible evidence. And I put that in quotes because as bibliometricians, we all know it's quite, you know, difficult to objectively define what best means, what's the highest quality evidence in this case. And it's probably slightly different. If you ask a policymaker what the best evidence is, it's not the same answer that you'd get from an academic bibliometrician or a research manager. So from a government perspective, when they're talking about evidence, they're talking about a combination of things, right? Not just the outputs, the research, but it's also how that research is framed, how it can be used in policy, how it's interpreted. And governments are interested generally in a more diverse set of voices. There's a recognition that, to date, maybe we've relied too much on, smaller networks of who knows who. They want research and evidence that's replicable and robust. They want it to be correct, basically. That's not how they would put it, but they want it to be correct. And they want it to be free from, there's a slightly older version of my slides, but they want it to be free from bias. And that's not because everything that the government does is unbiased, it's because the bias is what they're going to add later on. They don't want you to do it as an academic. That's the government's job. That's the political job, to spin it in a particular way. There's a final thing there which I would add, which is they also want it to be local. So the US government does not want to base its, hydrogen battery strategy on lots of research from China, right? That would be self-defeating for them. So there's that aspect of it too. So this is where we're coming from. This is what the kind of questions we're trying to help people with. Universities want it, funders want it, academics like it, and it's an area where we think bibliometrics can help. And it's a bit of a fuzzy line, really. When I say bibliometrics, I really mean scientometrics, I guess. It's never clear exactly where the one starts and the other ends, or if it's the same thing. But it's all in this area. I think everyone in this room has the capacity to kind of answer some of these questions. So in this talk, I'm going to briefly, and it will be brief because it's only half an hour, going to explore 4 things on the basis of the theme of the conference, being exploring the bibliometric universe. The things I want to explore are, first of all, this new citation network, which is public policy, policy documents and things they cite. A new data set related to that, which is engagement opportunities, and I'll talk about that in a minute. A new direction. So if you think about a lot of the work that you do with citation databases, you're doing a retrospective analysis, right? You're looking at what's already happened. And so I want to explore what can we do with the data that's prospective when looking ahead, kind of making more strategic decisions and helping academics or other research producers kind of do things in the future more successfully, or have a more successful outcome in those things that they do in the future. And then finally, I'm going to talk a little bit more on a kind of a practical level about something that I've already heard come up in 2 or 3 talks already. Diogo gave a really good talk earlier on about a great use of this, embeddings. I'm going to just talk about them briefly, about how we use them and how they can answer some of these questions. So first of all, just as a quick, do people know what Overton, the Overton database is, generally? There's nods. Okay, so I'm not going to go into detail. Basically, we're a big database of policy documents and the things they cite. We, at the moment, have these kind of 2 main outlets for that. So the first one is the app.overton.io, the kind of the main Discover index, we call it. And that's where all these citations are. And then the thing that we've launched recently, which is a slightly different model, is called Overton Engage, and that's related to these opportunities that I mentioned before. So just to take them in turn, and I will speed through this because I think we are familiar with it, but Overton collects, sometimes we say policy documents and people come up to us and say, oh, is that, have you got funder policies on, data retention, or like, oh, I work with my institution on policies, and what they mean is like HR policies and this kind of thing, internal organizational policies. So that's not what we track. We track public policy, so from government and IGOs, and those kind of organizations. And there's a bit of a nuance here, and you could hear it already when I say government and NGOs, IGOs, for example, which is that it turns out when you're looking at the policy world, you can't just track legislation or government documents around legislation. You have to zoom out a little bit wider and start including anyone who's on the interface. If you're interested in this research into policy question, you have to zoom out to capture anyone on the interface of academic and policy. So any kind of like knowledge brokers or people whose job it is to sit on that interface and translate scientific papers, do like literature reviews, into kind of policy briefs and policy-friendly language. And that's because policymakers don't read journals, by and large, right? There's some technical agencies and things where that is someone's job, but generally speaking, they're not reading, you know, the latest copy of Nature or browsing +1 talks or anything like that. So this knowledge translation step is important. Okay, so in the index, I'll skip over this, but because we have this big database of policy documents, about 16 million of them, you can, we go through them, each one. We look at the paragraph, each one paragraph by paragraph. We say, you know, is this a reference or a link to either a scholarly work or to another policy document in the database? Does it mention a person who we know is at a particular institution? And we kind of mark it up that way. And then because we've started, you know, we build out this kind of network thing, and we can link it to external data sources. And the kind of tool we use here, Crossref, for kind of matching the scholarly papers, and OpenAlex for a lot of affiliation data. We can answer queries like, show me all the policy documents where there's a citation from of papers that have at least one author at the University of Sydney, something like that. And why we do this, apart from the, you know, helping more broad kind of hand-wavy better evidence into policy thing, is typically to help people find policy impact, right? So because we have those links, you can say, okay, well, this scholarly paper is cited in this policy document, which is cited by this other policy document, which then we know had some sort of impact. And there's a bit of a, you know, final part of the pathway, just like any other kind of citation analysis, impact analysis, where you have to do some legwork and figure out, you know, was there an actual impact? You know, being in a policy document isn't impact itself. That policy document needs to have gone on to influence, had a change. And then that's the evidence ideally you need for something like a ref case study or a grant application, or when you're doing it at scale, the idea is that, you know, we can quickly say, okay, of your institution, here's 200 papers that you could look at that may have had a policy impact based on the data we can see. All right. So the crib sheet, again, I'm zooming through this bit to get to the embeddings part. If you only have one takeaway from this talk about policy citations, it should be these points. So roughly 5% of the scholarly literature is cited in policy at least once. That's all of the literature in, I mean, there's been two studies that kind of come up with very similar numbers, but one looked at all of Web of Science, one looked at all of Scopus. It's very different based on where the research comes from and the subject area of the research, and both of them we'll have a look at in a second. I mentioned knowledge brokers play an incredibly important role. So most research will go through one of these knowledge translation steps before it gets into policy. Policymakers cite local. I mentioned the US, you know, mostly citing US research. It's the same for almost every country. So if you look in, if you went into Overton and you said, okay, show me only policy from the UK, and then you looked at the universities that were cited the most or had papers cited the most in that policy, the top 5 will be from the UK. If you look in Sweden, the top 5 universities are going to be Swedish. If you look in the US, they're American, Japan, the Japanese. The only exception is in smaller countries where there's not a broad enough research base. I think we haven't actually studied if this is why the reason or not, but my gut feeling is the research base isn't wide enough to cover all of the areas that the government is interested in. So Singapore, for example, you get the 2 big Singaporean universities, and then you get the Australian National University, and I think it's Harvard or somewhere in the States, and this kind of thing. So there are exceptions, but it tends to be the smaller countries. There's no consistency in citation culture between, and by this I mean, policy citations have a completely different culture to scholarly citations, and also even within policy citations, in the policy citations world, one government is very different to another government. And within a government, one department is very different to another department in terms of, you know, how well are the assertions they make in a document backed up by references or footnotes or anything, and are they appropriate, or are they, you know, kind of undergraduate level where you might be like, oh, you cited the wrong thing there, you've not really read that, or this kind of stuff. And then finally, I just put this in as a, you know, as a side note, because we talked about what's the best research that could be going into policy. There's probably no open access advantage. It's quite difficult to prove this one way or the other. I would have liked there to be, but again, I think this is tied to the fact that policymakers don't actually read journals, and therefore open access is neither here or there. That's not to say there's not a good reason for the research underpinning policy to be open access, because it should be. We should be able to go and have a look at it ourselves. But in terms of discovery and getting extra citations, OA doesn't seem to make that much of a difference. Okay, the final thing on that is just this quickly. Social sciences get cited a lot in policy world, and the hard sciences don't. So something like quantum physics might be cited a lot academically, but policymakers are not citing quantum physics or organic chemistry. They're citing sociology and education and psychology and economics especially. And I realize Caroline mentioned this earlier on. For the eagle-eyed, you might have been might have noticed I used mean citations there. I apologize. Let's pretend that was a test and not just that I was running out of time when I was putting together these slides. But don't use arithmetic mean for citations. Okay, so that's the index part. And I'm going to talk about engagement and embeddings. So engagement opportunities, engage, and you can go to it now. It's free. You don't need a license or anything to log in, to create an account and browse it. Engage is a database of opportunities for an academic to engage with a policymaker in some way. So that could be an opening on an expert panel at the WHO or the FDA in the States, or one of the European Commission expert groups. It could be a public consultation about something where we think an academic expert might contribute usefully. It could be something a bit more formal, like a fellowship embedded within government. Or indeed, in the US and the UK now, there's a kind of a more formal system for the national government to kind of lay out its evidence, that where it thinks there's gaps in the evidence that it needs. So where it wants researchers to come forward in the next kind of 1 to 5 years, so normally kind of 2 or 3 years is the usual, with data and expertise that would be useful to the policy it thinks it's going to make in that time frame. That was a bit of a wordy way to say it, but we'll see an example in a minute. And in the UK, that's called Areas of Research Interest, and it's a free database that we worked on with the Government Office of Science at ari.org.uk. And in the States, they're called Learning Agendas. It's slightly different. It's a bit more complicated there because there's 2 types of learning agenda and this kind of thing, but effectively it's the same idea. It's the UK and the US government have said, okay, look, one of the problems with working with academia is we're not telling them in advance what we want. It's very difficult to plan and for funders to kind of appropriately adjust what they're asking for and things like that. So we'll start doing that on that kind of 1 to 5 year time frame. So in terms of what can bibliometrics do, or what's the opportunities here, what Engage does is we look at all the abstracts that we know about, again, from OpenAlex, and we try and map them to individual opportunities. So we say, is the person, the question, you can frame the question in lots of different ways. The way we frame it is, are the authors of this study able to contribute usefully to this question being asked by government, or this opportunity to engage with government? And by doing that to a whole bunch of abstracts and then taking the kind of closest neighbors in terms of similarity, which I'll again cover in a second, we can pull out the people from there. So we can say, okay, well, actually, these 2 abstracts are pretty close, and it turns out they're both authored by the same person. Therefore, this person, Professor Rosie at University of Bradford, might be able to contribute usefully to this policy engagement opportunity. And if I was a policy officer at Bradford, I might reach out to her and say, hey, did you know this was happening? It looks like it's close to your interests. The missing bit here, sorry, I sent my slides too early, but is that we can tweak this, a number of things that we can tell from a bibliometric analysis that are useful to this. So one is, are they, and remember the government is asking for a diverse set of voices, are they early career researchers, or are they further on? Are they doing, are they kind of doing newer, kind of riskier stuff around the edges, or is it kind of standard, well, I don't know how you would say that, core research work? Have they engaged with policy previously, or are they completely new to it? So we can, imagine some sliders there that help us suggest different types of people. So Engage does that. You should check it out. Happy to give you a demo of that, and Natalie's here as well. She can help too. But like I say, what we do is, I think it's interesting. I think we do it well, but you can also do it. So this idea of matching abstracts to arbitrary text and similar kind of problems, this kind of semantic similarity problems, it's figuring out if two things are talking about the same thing. It's a hot topic at the moment. You've probably used a lot of tools that do it already. If you think about something more complicated around like chat-based interfaces, the Scopus AI stuff, all this kind of thing, at its core, the base level of that it's all built on is this thing called embeddings. And it's the same kind of technology, or probably exactly the same models that are being used for things like detecting predatory publishers, or some ways of detecting paper mills, using kind of textual data, using abstracts and the full text of research papers. And where it all comes from is work done at Google, well, and lots of other places, but a lot of the work is done at Google quite a long time ago. You'll notice nowadays, this is the real story. I think this is the the extra slider stuff on Google. I think it's because who I'd been searching for recently, but there you go. Google says it's true. Where you'll notice if on Google you can go and ask a natural language question, it'll still give you quite a good answer related to the way you're doing it, and it's because it's not just keyword search anymore, right? There's something else happening under the hood, and to simplify it greatly, a lot of the stuff that's happening under the hood is based on this idea of semantic similarity and embeddings. I am not going to try and explain what embeddings are, partly because I'm pretty sure I would get it wrong. But also, there is a lot of data on the web. What I want you to take away from this is it's not actually that difficult to do. It's difficult to understand the maths behind it if you really want to go back to kind of the very basic building blocks and build up from there. But essentially, embeddings are a way of representing any block of text as a vector, as a series of numbers. And that's created by a model. The most famous model is BERT. It's called like Bert and Ernie. And that's the model that was created by Google many years ago. And it's been developed since then. There's different variations of it. But effectively, you sometimes read about BERT. What BERT is doing is taking this text and it's converting it to a vector. And it's doing it in such a way that similar words or phrases or sentences are closer together in space, in n-dimensional space. And this is, where I won't go into too much detail. And if they're not so similar, they're further apart in terms of semantic similarity, in terms of distance. There's lots of different ways of, calculating that distance. You hear about cosine distance being a classic one, but there's some other ones as well. The key thing is that we take some text, we convert it to a vector, and then if we compare two vectors, we can see how similar they are by looking at the distance between them. The thing about it is that nowadays it's very easy to do this, and it's very cheap to do this. So you've got two ways to do it. You can do it on your local machine. It doesn't, you don't need to be an IT expert necessarily. You can literally download an app. There's an open model, a program called Ollama. You can download onto your desktop, onto your the Mac, and install various different models, and then there's kind of an interface, an API interface that opens up to do embeddings with them. Or you can use an off-the-shelf service like OpenAI, which does ChatGPT, and it's incredibly cheap. So with OpenAI, I can't remember exactly how many it is, but they use tokens rather than characters. Without getting too much detail, works out to roughly $1 per 200 million characters. So I'm just going to run through very quickly an example of this to show how easy it is. So if we take a question like this, so I've talked about UK's government UK government areas of research interest, what the UK government is currently interested in hearing from researchers about. Let's try an experiment where we take all of University of Brighton's research, we just throw it against those ARIs and see if anything comes back. This is not a sophisticated analysis, but it's just to show you what the beginning parts of what you could do are. So I said OpenAlex was coming up, and here it is. It's a very easy way to get data from, yeah, exactly. I think it literally took me like a minute, if that, to log into OpenAlex. You don't need to log in. Go to OpenAlex, type in University of Brighton. I restricted the date field to 2024 just to make it a bit quicker, and then export it. And when I export it, I also get the abstracts and a whole bunch of other metadata. So that's my first input data set, is abstracts of University of Brighton research data 2024, research outputs 2024. Then my second one is the UK ARIs. This would be an even better demo if I could say you could download it with one click in less than a minute from Engage. You can't. But you can get all the ARIs. We have an API and a data dump up on the web. You just have to parse it a little bit. So we're going to get the text of each of those ARIs. And the text of the ARIs is typically, goes into a little bit more detail about what the opportunity is. So we showed one before here. The ARI typically has 2 bits. One is the question. So in this case, it's the thing at the bottom there. The questions being asked by the Department of Education. What is the impact of children's access to nature from an educational and well-being perspective? What I don't show is there's a little bit extra blurb there, kind of almost like the abstract for that ARI, which is a paragraph of background text. So that's going to be input set number 2. Then there's lots of different ways of creating embeddings. How many people are familiar with Python? Yeah, it's quite good. I think this is just an aside. I think the number one thing you could do as a bibliometrician to kind of power up, go up a level, is to learn a little bit of Python. I actually don't program Python. Overton's written in a completely different language. But for this kind of stuff, it's great and it's not complicated. There's 2 scripts involved. One takes in a bunch of input, those 2 sets that we created before, and creates embeddings for them. And then the second script just compares every element in set A with every element in set B. And if the distance is less than a certain threshold, which is completely arbitrary, print out that pair. Almost all, there's no way you can see it up on the screen, so you have to take my word for it, but almost all of the code on that left-hand side is loading a file and extracting a line of text from it. The actual creating embedding bit is probably 4 lines of code. So I ran that. I think for the University of Brighton, for the 2024 thing, I think there was like 500 or 600 abstracts. There wasn't a huge amount. And there's about 3,000 ARIs that are currently active. So we did all the embeddings for that. I used the OpenAI API, and it cost me less than 1 cent. It took about 10 minutes to run, I think, going one by one. So you can see it made, sent 684,000 tokens, about 3 or 4 characters roughly per token. And the Python code I didn't write from scratch. Again, I'm not a Python expert. I asked ChatGPT, I said, write me a script that, if I give it a text file of, these inputs, use the OpenAI to get me embeddings. So it's easy. And what I get back, again, this is unsophisticated. To actually use it, you'd probably want to do a bit more, put some more guardrails and do a bit more thinking about what it all really means. But you can see it kind of works. So at the top, it prints out a bunch of pairs. And at the top, you'll see an abstract from Brighton. It published in 2024. And in the bottom, you'll see the ARI that it matched to. So here, the ARIs, the Department of Education, again, is asking, how can we best support children and young people with developing resilience and mental health throughout their schooling? This is the wrong, this is the wrong slide again. Okay, let's skip that one because I made an error with the wrong button. Let's go to this one. What are the potential risks or unintended consequences of counter-disinformation interventions from the Department of Science, Innovation and Technology? And it turns out there's a piece of research from Brighton that is a systematic review of digital interventions against COVID-19 misinformation specifically here. And one of the things it covers is the accidental unintended consequences of those interventions. So the idea is, can you once you've gotten the hang of this kind of semantic similarity thing, can you start imagining ways that you could combine these data sets together to be useful for people in that institution, either retrospectively in terms of what strengths do we have that we need to develop in the next 3 years, or where can we point researchers to maybe have a policy impact that's real. We know the government's asking for it, and we gave them some answers. Okay, so my key takeaways. Bibliometrics can go beyond scholarly outputs. You can look at these other data sets as well. Policy citations, I mentioned those, the crib sheet earlier. They're familiar, but they are very different. You can't just assume that it works exactly the same way. Don't just think, retrospectively if we're thinking about analyses. Think about prospectively too, strategically. How can we influence strategy, or how can we feed into future strategy rather than just looking back at what we've done? And embeddings are not that hard. I'm happy to share any code if it's worth it, or to talk more about that. And then finally, if you're experimenting with any of these ideas without kind of preempting anything, we do have a micro grant program. We want to know about any interesting stuff you do with our data for sure. Please do come and talk to us. Thank you.
Okay, well, thank you. That was a lot to take in. So does anyone have any questions?
Really interesting. Thank you, Euan. Have you had examples of where you've presented your findings of this embedding, of matching the papers to the open research grant calls to authors, and have authors applied as a consequence of that, or had responses that are interesting to you?
So we've used this matching, I guess, so we built the database originally with the Government Office of Science, and it funded by UKRI, and so it's been used in that sense, in the UKRI looking at it. And there was a report that came out yesterday, I think, from Nesta and ESRC about the state of global evidence. And one of the things they use is, how well do UKR grants match up to what the government's asking for? And then they break it down by departmental spending and this kind of thing. So in that sense, that's where the kind of data has been used. But we've not done it. We just launched Engage. I think it's being a beta test, but it's launching at the end of this month. So we've not done it with individual institutions yet.
Any more hands?
Thank you. Well, congratulations! What a amazing development in the platform. Just wanted to note on this element of finding experts on the pairing. You mentioned that you are thinking of developing these filters, and I just wanted to say congrats, and please go in that direction. Also enabling to filter, not to have the common researchers and the common advisors that are always there and already know what types of language and how to phrase what they're doing in terms to be picked up. So having those filters for diversity in terms of nationalities, ethnicities, gender, to also just enable us to find the new voices that we need to find to influence policy. That is such an amazing way to go. Congrats. Thank you.
Yeah, thank you. I agree. Yeah, that's a really interesting part of the system. So having said that, we haven't worked a lot with universities. Obviously, we've done some beta testing with people. One of the interesting bits of feedback is people say, "Oh, well, I recognize these names. I don't recognize them." And you're like, it's a bit of a mixed bag, because you want both, right? You want the names where, you as an expert in the university say, "Oh, yeah, they would be great at that." But you also want some of these new names that they've not heard of to kind of expand out a little bit.
We do have a question from online.
A question from Karen Rowlett. She asks, Euan says, this is all easy to do, but difficult to muster this expertise in institutions sometimes. Is this the kind of analysis you can use Overton Engage for?
So kind of the off-the-shelf bit that Overton Engage will do is people at your institution, how do people at your institution match up to these opportunities? And then we have some semantic searching stuff where you can put in like a project description or somebody's bio or this kind of thing and get back opportunities that are matched to them. So the off-the-shelf bit that we do at Engage is really focused on just your institution. To do the kind of broader stuff, you wouldn't be able to do that in the app. You'd have to take the data and do something else with it.
Thank you so much for your presentation. I'm a fan of Overton, I have to say. And my bibliometrician mind was thinking how we can maybe combine different databases with, so the same experiment that you did with OpenAlex, like do it with Web of Science or Scopus and see if there is some discrepancies in the results or no, or there is an alignment of, I was thinking, do you think could be differences between the results, or with one database would be enough?
I think you definitely get different results just because that, I think that there's going to be a core, it's like the diagram Jason showed, I guess, where it all comes down to the affiliation data and how good is it. It's the old bibliometrics problem, right? Like, how good is the affiliation data in each one of those databases for your specific institution? So if you've worked really closely to clean up your author profiles in Scopus, then actually you're going to get much better results with Scopus when you do that pool initially of like, get me all the abstracts from our database, from our researchers rather, than with the other ones, and vice versa. If you haven't done that, you might be better off with OpenAlex because it's bigger, or this kind of thing.
Any further questions? Okay, well, thank you very much, Euan, and thanks to all three of our presenters in this section. I think we can now go and have some tea.
everyone. Introduce our next speaker for this session. So, William Mischo from University of Illinois. He is working about bibliometrics in the Urbana-Champaign library, and his talk will be covering bibliometrics and research applications, application templates at the University of Illinois at Urbana-Champaign library. So I'm now going to hand over to him.
Yeah, I've got the lavalier mic. Can everybody hear me okay? All right, good, good. Yeah, I'm Bill Mischo from the University of Illinois. It's a presentation that my colleague, Schlembach, was watching on YouTube. She tells me. We have a Bibliometrics and Research Impact group at Illinois. We're trying to start a more formal service. A lot of U.S. libraries have formal, what are called BRI, Bibliometric Research Impact Services. We're trying to get to that point. Everybody here knows that there's a great deal of library involvement now in BRI activities. We, as are many of our colleagues at other institutions, are partnering with university units in terms of research, indicator gathering, supplying metrics for promotion and tenure, for grant requests, hiring decisions, program evaluation, et cetera. These are all things that, almost all academic libraries are now working on. We're also very concerned with responsible use of BRI metrics. We're all familiar with issues surrounding Cora. We follow in norms and Light Manifesto and have the same concerns with research metrics as everyone has in terms of overuse of journal impact and H indices and the fact that a lot of the Scopus and Web of Science, for example, the services we normally make a great deal of use of, are very Western in focus and sort of monolingual in terms of their coverage. So what we've been working on sort of by demand is establishing these templates or scripts that our colleagues in the library can use for research projects. More and more we're using bibliometrics for research projects. We are still partnering with the research centers, and I'm going to give you an example here of something we're working with at the Cancer Center. But we are focusing more and more now on providing BRI support, background services for library colleagues who are subject liaison librarians or subject collection specialists, to give them this sort of deep background information that's useful for them when they're talking to faculty that they're supporting in a variety of ways. It's also a really growing interest in BRI as a research area. We're seeing a lot of publications, obviously, in this area. I went and looked at Scopus the other day, and there's 25,000 title matches with the word bibliometrics in, and just going from 2020 to current Scopus is over 18,000 articles. So, we're seeing these in library journals, we're seeing these in scientometrics journals, we're seeing these in disciplinary journals, a lot of studies on bibliometric and research impact. So we're working on a suite of these sort of BRI application templates or scripts, and I'm going to sort of run through these in a hurry. Some of you may be working on the same sort of projects. Some of you might be interested in how we're doing this and what we're actually doing. One of the neat things here that we have at this point in time is that we have a myriad of tools at our fingertips. A lot of different APIs from A&I services, vendors, disciplinary repositories. We've got great visualization software. And we're just beginning to get more involved now with, on the library side, with machine learning and as we've heard a lot this morning, with AI algorithms applied to BRI work. At Illinois, we're using a lot of Scopus API and Pure API, SciVal Pure. We do use Web of Science API. But we have the same problems with that everybody else has in terms of distinguishing author affiliations and the extra charges we're paying for the advanced API. As an example of the use of the APIs, we have a discovery service, a bento-style discovery service, which a lot of institutions, particularly in the States, have. And a typical search in our discovery unit, which is called Easy Search, we're doing about 15 API calls. So we're using API calls into EBSCO EDS, into Primo, and into Scopus, and then supplementing those with these value-added links from OnPaywall, from our research people, Altmetric, it's Altmetric actually from digital science, Scholix to get links to data sets that are connected with articles, Bing API to get web-based information. So a typical search is using 15 API calls. We have the tools now where we can do this very fast and very efficiently. We're also looking at a lot of new machine learning and Gen AI tools. I'll talk a little bit about that later. So we're still doing research impact visualizations for departments. These are sort of dashboards for departments and research groups. The one I work with very closely is the Cancer Center, again using the Scopus API, the Pure API, custom scripts to create visualizations. These begin with a table in the Microsoft Access database or SQL Server database with the names of the researchers and the Scopus ID numbers. And then we've written additional scripts to create a whole series of other visualizations. Our Cancer Center is trying to receive a NIH Cancer Center designation. And so these are being used in this grant process. We've expanded these visualizations to 11 other departments in the College of Engineering. I'll show you what some of the products are that we can derive from that. So we're using the typical indicators, articles published, citation. We're also using site score metrics for journal impacts, number of NSF and NIH grants, patents received, list of co-authors. NIH requires a visualization or indication of co-authors within the cohort in terms of articles. So this is a database-driven, interactive, web-based, and you see what we generate are display bubbles that are clickable, and we can use this. We're using the same scripts for all the different departments in our research groups, and some of the tools we're using are scalar vector graphics and some JavaScript libraries. So the tool is, and this is actually bioengineering faculty. You'll see the individual names of the faculty members. Here's a close-up. Again, all the bubbles are clickable. So if you click on the bubble with articles, it will actually take you into a database that will give you author title, author impact, abstract. This is all data we've gotten from the Scopus API, metadata that we've pulled out of the Scopus API, but then a number of citations, grants, co-authors, and then co-authors in the cohort. So this is one particular faculty member, and then the number of articles that he has written with other researchers in the Cancer Center group. But again, what we've been doing a lot more of now lately is looking at supporting the subject liaison librarians and collection specialists. It's important because we're giving them information on publishing patterns, research fronts, collection gaps. One of the things we're looking at a lot is how many of the new Nature, Springer Nature journals we can afford. Question we get a lot is how many of our researchers are publishing in these journals. University of Illinois is an R1 research institution. Well, we have about 59,000 students on site and online, several thousand faculty, offer research program, PhD programs in a lot of different areas, separate medical school. So we have liaison librarians for a lot of different departments and groups. So we build these custom relational databases that we use to generate information. This helps with the liaison librarians with faculty interactions. They know the research trends. One of the things that we all know is that research faculty love to talk about themselves. Very happy to go to talk to you about what they're doing, but it's very useful to have some idea, some sort of deep background when you go to speak with them. We're also doing some library research projects utilizing BRI technologies. So for example, here's a list we generate from the Pure data. These are the publications from 2014 to 2019 by faculty that are in our Pure database, which is pretty much all the faculty at the University of Illinois. You can see this is dominated a lot by open access journals. Literally the most popular journal at the University of Illinois in terms of publishing is PLOS One, Public Library of Science One. Turns out this is really only being done in a few different colleges. I'm going to show you a list of journals from the College of Engineering here in a second, and you can see they're not publishing much in PLOS One. In fact, it's not considered a major academic journal for promotion and tenure decisions. But typical usual suspects. We have a very large, well-known, internationally known chemistry department, School of Chemical Sciences. Journal of American Chemical Society is heavily published in the PhysRev journals. But you see, in terms of the open access journals, we've got PLOS One, scientific reports. We're a Scope 3 member, so Journal of High Energy Physics. It's now an open access journal at CERN. Contracts with publishers for high energy physics journals. We pay them a set fee. Those are all OA journals. European Physical Journal, Particles and Fields, same way. Nature Communications, 180 articles in those 5 years. Nature Communications is a gold OA journal. It costs $6,000 to have an article published. That's the APC fee. But you can see we also have a large vet school, so Journal of Dairy Science, very heavily used journal. Here's the journals that the College of Engineering people are publishing from 2012 to 2022. So this is information we can give to a liaison librarian, for example. So this tells them that what the major journals are. We literally put together databases that we use to generate these reports or these lists. Again, very heavily weighted here to open access journals, but we've also done generated a lot of longitudinal data. So in some cases, we've got this particular report goes from 2012 to 2022. Scopus has done a great job of going back and indexing major journals back to volume 1. I'm going to show a project we worked on, Journal of American Chemical Society, literally back to 1870. So we can do longitudinal studies. We can look at patterns, author publication patterns, research patterns, research trends, how research fronts have changed. One of the things we're doing with AI tools, machine learning tools, is looking at topic modeling. So we've been using a couple of topic modeling machine learning algorithms, k-means, spectral means, to try to generate by decade, for example, how research fronts have changed in particular areas. So this is, you can see +1 here. It's down in the bottom of the list for Granger College of Engineering, although there's still 115 articles published in that journal from this time period. One of the things as research librarians that we haven't done a very good job of is really understanding the research environment outside of our doors. What's going on in other in other parts of the campus, what journals people are publishing, what's critical to their needs. But this will literally, we can give people a list of journals from Scopus that we're not subscribing to, that our faculty are publishing in. Another project that we've been working on, this that would segue into this idea of topic modeling. So we're working with some of these machine learning techniques. We use a lot of the scikit-learn tools and the Microsoft Azure Cognitive Toolkit. They actually have a OpenAI toolkit now where you can use the ChatGPT API and some of the other machine learning tools that they've produced from ChatGPT. So we can offer these topic modeling services where we're literally telling people what topic clusters are important for a particular research center. So we've done this with the Cancer Center. We've taken the 8,000 publications that the 80 faculty have done from the Cancer Center, tried to generate, identify, characterize the research by assigning major topics to the research, which is something that they've been very interested in. This is an article that I co-authored with some civil engineering faculty members. It's in a journal of Renewable and Sustainable Energy Reviews. We pulled out, using the Scopus API, 57,000 articles on biofuels and did a topic analysis to see over the last 10 years how focuses in that area have changed, how that research has evolved. And that again uses a particular clustering technique called CTM, comparative text mining, to identify these key topics. All right, so there, as most of you know, there's a very rich literature on research evaluation and measurement. A lot of the focus in this literature has been on citations and relationships between research and publication indicators. We've done several studies. This is a page of a study that was published in Science and Technology Libraries by my colleague, a co-author on this presentation. Longitudinal study on dissertations in chemistry and physics over 50 years using bibliometric techniques. We also did a study for published in Journal of Academic Librarianship on data reuse, where we used the Scopus API to pull out the most cited articles in 8 subject areas on campus using the 34 Scopus subject descriptors. And then email authors and asking if they generated data from these articles, use that information in the survey, and then use the Scopus API. We're getting permission from the Scopus API people to actually give us the email addresses of all the citing articles of these most cited of UIUC Illinois articles, and then asked those people if they had used the data from this article. So we got a lot of information here on data reuse. And then an article here, March 2024, in the College of Research Libraries, where we looked at relationships between publication, citation, and usage metrics. Here's a citation to that article. One of the interesting questions in bibliometrics had to do with the relationships between journal citation counts, usage data, authorship, how these correlate. Do the journals that are most cited, are they the most published in? The journals that have the highest download frequencies, are they the journals that are most cited and most published in? So we gathered a lot of information. In this case, we used the LJUR, Local Journal Utilization Reports from Web of Science, and then the download data from the Project Counter data for downloads of journals. did correlation analysis. This is important for collection development decisions, liaison work, core journalist generation, identifying research disciplines on campus, and also trying to see if one of these indicators or metrics can serve as a proxy for the others. So for example, if you know how many times a journal has been downloaded in the last year, does that actually correlate highly with the number of times are people published in the journal or cited the journal or its journal impact factor? All the previous studies used pretty much a small number of journals in narrow fields. Our study looked at 13,000 journals in the entire collection. We found that there was a high correlation between downloads and local citations, although there was major differences by discipline. And then we found, interestingly, that if we looked at the authorship information, how many times the journal has been written in, and local citation, what our people are citing, there was sometimes a disconnect, and it pretty much had to do with the aspirational publishing hopes of faculty. Some departments that we found that were not are highly ranked departments on campus, people were citing journals that they weren't able to publish in. So they weren't published in the same journals that they were citing. And so we generated, we've got tables and tables in this article, correlations between data on local, what's been locally cited by our people, what's been written in by our people, citations by outside authors. We get this information from LJUR, and then the download information. Are the journals that are most heavily downloaded the same thing that are same journals that are being most heavily written in? And we also looked at SFX click-throughs, although you can see the correlations here are not very high. So we didn't find a high correlation between SFX click-throughs and the other indicators. But often the eigenfactor, normalized eigenfactor correlations are fairly high. In a subject area like engineering, correlations were very, very high. We've got one of the top-ranked engineering programs in the world, and our authors are publishing in the most cited journals. Some major questions in bibliometric studies. I think all of you have seen a lot of these articles. This is something we got very interested in. Are multi-authored articles cited more often than single-authored articles? Are articles with co-authors from more than one country cited more often than articles where the collaborators are all from a single country? And then a whole raft of other areas where people are interested in relationships between number of pages and citations, although to me that's a very odd thing to look at. Open access and citations, a lot of literature on that. Tweets and citations are the articles that are being tweeted about the most. Are they also being cited the most? And so, and again, here's an example of a typical article in a subject discipline. So this is in an ecology journal where they're very interested in a lot of these classic bibliometric techniques. This is part of the 19,000 articles that you can find in Scopus and bibliometrics in all sorts of disciplines. Another classic example by an author that does an awful lot of writing on this, Rousseau, about our multi-author articles cited more often than single-authored ones and international collaborations. So we did an article just last year in Science and Technology Libraries on authorship, citation, publication characteristics across 130 years of JACS, Journal of the American Chemical Society, where we looked at some of these questions. So what we did is extracted articles from 6 universities. So we looked at 6 top universities in the US, and then using the Scopus API, going back literally to late 1800s, to look at the authorship patterns, relationship of citations to multi-authored articles. So you see some of these tables, we did this by decade, and we've got scripts and templates that allow us to do this now literally with any journal or any series of journals or any journals on any topics. Interesting to look at like average number of authors. You'll see 1890 to 1900 or 1930, there was like 2 authors on each article. Now we're up to 6 or 7 articles per author. Number of articles, authors that are within the institution. You can see that that's gone down. Non-institutional authors has gone up. So 2011 to 2020 is typically average of 2 non-UIUC Illinois authors publishing the articles. Single author has gone way down. Multiple author has gone way down. There's totals single author, highest number of authors. You know, Derek DeSola Price predicted that by 1970 or whatever the date was, there would be no single authored articles in chemistry. That's almost true here in JAX. And then looking at collaboration ratio, average number of citations, uncited papers, average number of OA papers, and you can see way back in the before 1900, almost everything now is OA, and then it drops way down, and now it's coming back up again. International authors, number of international authors has gone up to 30%. So this bibliometrics, all this metric works, these enhance the role of the library. We've done some other follow-on studies, which I'm not going to get into, where we can actually now, we can look at the correlations that we've got with, after we've gathered this information, we can look here at whether or not the correlation between the number of grants an author has and the number of publications, patents and publications, all these indicators. Apologize, this kind of disjoint. I went through a lot of different slides. We've kind of clammed together a bunch of publications here. But I hope this gives you some idea of some of these sort of exemplars that we're trying to write, where we can take the same sort of techniques and scripts and apply them in different subject areas and different environments.
Yeah, thanks very much for the presentation. We did have some questions from the online audience, but your colleague answered them already.
Good.
So I will not repeat them, but just wanted to ask here if anyone has any questions. Okay, I can't. Okay.
Thank you so much for your interesting presentation, and see the bibliometrics service at the University of Illinois. Yeah.
Right.
So
and
thank you.
And a lot of other institutions are working on the same sort of thing, but.
So yes, my question is about when you did this publication using topic modeling to identify concepts. When
the topic modeling?
Yeah, topic modeling.
Right.
So I just a bit of curiosity. What was the reason to use topic modeling rather than other bibliometric techniques such as clustering,
that was something
analysis?
A number of people asked us about. I mean, we had a lot of. I mean, machine learning. The two big areas that people are working on are clustering and classification. So the clustering algorithm is sort of unsupervised. You look at a lot of documents and you try to figure out what are these documents about. These are AI machine learning type techniques, and they use the same sort of thing. Vectorize all the documents, do a similarity coefficient to see if the documents are the same, and try to identify clusters of documents. I would say that effort has not been that successful. I actually did a presentation at a Center for, CLI presentation on machine learning techniques, and a lot of libraries have tried to apply these, and the clustering techniques aren't very good. The classification techniques still have a lot of work to do also. Classification is where you train a number of documents. You look at a document, you say, well, this is about this topic, topic A. This document is about B. The third document is about A again. Fourth document is about C. And then you present a new document to the system, and it says, well, that's either A, B, or C. You're trying to decide what general topic a particular document is about.
Yep, thank you.
There's a lot of work that needs to be done in that area, though, before that's going to be useful.
Yeah, I would like to thank you again. So now, hopefully we will move to the next session in a few minutes. The next session is going to be navigating the research landscape, real-world examples of using Inspec Analytics to chart societal impact, government funding, and industry academia collaboration. So it will start very soon. Thanks.
Welcome, everyone. Welcome back. Now we have a presentation from our colleague Tim Haken from IT. So we're going to navigate the research landscape, real-world examples of using Inspec Analytics to chart societal impact, government funding, and industry academia collaborations.
Thanks, Mom. Can you hear me at the back okay? Cool, thanks. Hi, everyone. Some of you will be familiar with the Institution of Engineering and Technology. We're a non-profit organization with the largest membership society for engineers in Europe, 157,000 members. We accredit engineering courses in universities, including the University of Brighton and a bunch of others in the UK. And we're a learner society for engineers and technologists based in Stevenage. So we also publish journals, we publish books, and we make the Inspec database. The Inspec database has been around in one shape or another since 1898. It went electronic in the 1960s. We were one of the first ones to go electronic. It's an abstract and indexing database covering 25 million research articles, covering engineering, physics, and computing and control technology. So what I'm going to talk about now is 3 ways that our Inspec customers have used Inspec Analytics, which is a new analytic application we've built on top of the Inspec database to solve real-world problems that they're facing. Oops. Yes, here we go. So I'm going to talk about 3 specific examples. So Concordia University, where in fact the engineering department has come up with a course for engineering undergraduates, for faculty, which uses the thesaurus, the Inspec set of control terms, which we use to index the database, to map societal impact of emerging technologies during the COVID pandemic, and looking at global and regional trends for those particular topics, gender pay gap and things like that. Another one, Syracuse University in New York State, where they've been using Inspec for a long time. They've worked with us to develop the Inspec Analytics tool. And they are identifying specific areas, specific subjects they can modify their syllabus with in order to be a better provider of local engineering graduates for a local employer due to the semiconductor reshoring work that's going on in the US, which involves lots of money. And for MIT, requests from the provost to understand what work they are doing with whom on which potentially risky topics because of changes in federal policy in the US over the last couple of years. So I'll go into each of these in detail. Firstly, though, for those of you who aren't familiar with Inspec, it's an abstracting and indexing database. As I mentioned, has over 25 million articles going back to 1898. We've got journal articles, we've got book chapters, conference proceedings, etc. And it covers our core topics. We're a learned society for engineers and technologists, so we don't do the psychology stuff, we don't do the medieval French literature stuff. We're focused on the hard science and engineering. And we have a controlled vocabulary of thesaurus terms which we have developed. We curate and we update every year to allow us to allow our users to find very, very specific sets of articles about very, very niche topics. And we manage that, we bring the content in, we apply the indexing, and then allow people to find it. That's very well respected in engineering research. Obviously, the thesaurus has broader terms, narrower terms, lead-ins and related terms, so people can navigate the thesaurus to find the set of articles they want. And obviously, as part of bringing the content in from the publishers, from the publications, we map the institution affiliations, author affiliations, authors, date, publications, citation counts, references, all that as part of the database. And we built the Inspec Analytics layer on top of that to allow people to easily navigate it, to be able to find solutions to their problems, which trends are emerging, what are the top research areas going on in Egypt, who's citing work on which particular topic, what are the key topics and buzzwords that people in my department could be working on, who's funding all this research as well. So our thesaurus is, some systems say this article is about engineering because that's what the journal says. We go deeper. We say there's different types of engines. There's internal combustion engines, I'm a chemist, I don't understand all this stuff myself, but there's dual fuel engines and there's heat engines, and then more specifically than that, you don't want to find an article on heat engines, you want to find an article specifically about Stirling engines. And then you want to see what are the top cited articles on Stirling engines. And again, the articles don't necessarily contain the word Stirling engines. We apply the indexing, so you would find articles you wouldn't find elsewhere because our subject matter expert has said this article is actually about Stirling engines, which are really cool things, by the way. You should Google them. They're really cool things what Stirling engines do. So we allow people to find specific sets of articles, and literature discovery is extremely important, but obviously people want to know what's going on in their field. People work in a specific area of engineering, of semiconductors, of geophysics, of astronomy, and they want to know what's happening in their particular type of subatomic particle, their particular type of galactic object. So we also apply the Inspec subject classification, again, quite long in the tooth, very well respected. This is a 5-level deep subject classification. So an article, so at the top level, an article will be about electrical and electronic engineering, but more specifically than that, it may be about components, electron devices and materials. More specifically than that, it may be about superconducting materials and devices. More specifically than that, superconducting devices, and even more specific than that, superconducting coils and magnets. And there's all of these different types. There's 3,600 different subject classifications. And the hierarchical, so you can mine down within it. You can see what your organization is doing in electrical engineering, or you can navigate all the way down to see who are the top cited organizations in the world, who are the most prolific authors in the world, publishing research on superconducting receivers and detectors. And again, this is information you will not find on Google Scholar. The articles may be on Google Scholar. They may be in lots of other sources as well. But those systems don't know that that article is about superconducting cores and magnets, because our indexer has added that. And for each of those 3,600 subject classifications, we've built a concept page in Inspec Analytics, which allows you to see the trends of articles about that specific topic over time for any one of the 36,000 organizations in there. and globally as well, so you can see what's happening around the world. You can see within that topic what are the other emerging topics as well, because we don't just apply. One of the comments in the previous talk was, if you try and apply one subject classification, it may be wrong. So we apply multiple subject classifications and multiple thesaurus terms, so you can see actually this article is about 3, and within that, one of these is really highly cited. Or this article is particularly highly cited for that combination of topics. You can see what are the top journals, what are the top conferences. That's either article count or citation count on that particular niche topic as well. So researchers who are looking to improve their publication profile can actually see which conferences they should be going to network, or which journals they may want to try and approach, because articles in that particular topic get cited more for that particular subject. You can see what an organization's competitive ranking is for that particular topic. You can see what are the co-occurring concepts, and you can see related terms and authors and funding bodies, which of the tens of thousands of funding bodies worldwide have funded research on quasars versus neutron stars versus pulsars in your particular country. And we've done that, generated concept pages for 3,600 subject classification codes, 10,000 control terms, and for 35,000 organizations, the majority of which obviously are academic, but there's quite a few corporates and government bodies in there as well. So, to dig into Concordia. So we monitor usage of the database, and we saw people, the numbers of searches going in was massively jumping because they had developed, as it turns out, we thought they were hacking us, but they weren't, they were using it. University of Concordia is a well-known, well-rated university in Canada. They're known for innovative approach to things. They want to really teach the undergraduate engineers not just how to do engineering, but what the impact is on the world and the social ramifications of the work they're doing. So they developed the Impact of Technology on Society course. It's a mandatory course for engineering undergraduates, because what we found when talking to librarians is Generation Z, the students that are coming up now, are what they describe as informationally illiterate. That younger people have learned how to use smartphones and have learned how to use Google and various things like that, and they think that is knowledge. So they don't know to go to the library, they don't know about structured data sources, they don't know about data quality, it's mostly about convenience. So they have to go through a process. In fact, when I went to university here 25 years ago, a long time ago, I remember when I was doing a chemistry degree, we all had to take a basic course on maths. We all had to learn, as undergraduates in our first year, how to add up, which was ridiculous because we'd all got into a chemistry degree. But it was to give them all a common basis of, everyone knows how to add up now, so then we can move on to the next step. So now engineering universities are running similar things on how to search literature, how to find good quality data sources. And also, what's the impact this is having? So things like they wanted the undergraduates to work together, to work in a group, to go out to use library resources, provided Inspec and other sources too, and then to be able to understand for these emerging technology concepts, who is working on this in Canada, obviously it's a Canadian-focused course, what funding is available from the government, which corporates are working on it, is there a gender disparity, a pay gap in between men and women in Canada, and then what's the citation impact and patent ramifications of that. So they used Inspec thesaurus terms as the set of concepts. So things such as, for example, in the bottom left, neural networks, wireless sensor networks, facial recognition, machine learning, these are all some of the Inspec control terms, like Stirling engines and heat engines I was talking about earlier on. And so the students had to go out and look at, there are actually a dozen different topics. They worked together in groups and they built these courses looking at, in fact, if I just click onto the next slide, and they built these beautiful visualizations. There is a 3D barcode there which you can click on, which takes you to the Prezi presentation. And there's YouTube videos as well of them presenting their work. And this is seen as a very successful course developed by faculty using library resources and using information sources to teach them how to work together and how to understand the ramifications of the work they're doing to place it in the context of wider societal development. And we love it. And again, VosViewer, all of you have heard of VosViewer, they use these various tools. They don't just use Inspec, they use VosViewer, they use Compendex because they're doing this on the Engineering Village platform. and various government database and statistics. So it's finding the literature which is indexed with that particular topic, and then going off and searching for that information online, finding which institutions are doing the work, mapping all this out and presenting it back. And that's seen as a very successful course for undergraduates. The students were very happy, faculty was very happy. Obviously, we're very happy because people are using our database. So that's one example of a university developing their own course based upon information and resources, based upon analysis of the number of articles, the number of citations, the number of funding bodies, the amount paid by corporations on these particular topics. The second one is Syracuse. I did give a 10-minute lightning talk about this earlier on this morning, so some of you may have seen these slides. But this is a slightly different example of Syracuse University in New York, who are preparing for reshoring. Now, reshoring is a concept that's fairly new. That everyone knows about globalization, the fact that you've got companies in the US and Europe who are designing microchips, and then they're being actually produced and manufactured over in China and Taiwan. And then during the pandemic, and when workers weren't going into factories anymore, there were problems with getting electronics back into the US. And they saw this as being a geostrategic risk. So what they developed was the Chips and Science Act, which is creating helpful incentives to produce semiconductors. You've got to love American lawmakers. They always find an acronym. The CHIPS Act took what's technically known as a ridiculous amount of money, $280 billion. Figures vary depending on exactly which source you're looking at, but $280 billion, of which $13 billion of that was for research and workforce training. So there's a large amount of tax incentives, of grants, funding for different places. Part of this is to replace fossil fuel mining in certain states, and they want to replace that with battery production, or designing chips, or producing chips, actually making them in the big, they're called fab plants, fabrication plants, with the people wearing the white suits in the clean rooms. And they want that to happen in the US rather than all happen offshore. What they found, though, was that when companies were doing this, when the big semiconductor companies were actually doing this, the local population were not qualified to work there because they built a big plant and then the local people just didn't know how to work in there. So they ended up spending a huge amount of money, bringing people in from Taiwan and other countries to train the local workforce on how to actually make the chips. So in the news, Wall Street Journal, there's a big company called Micron Technologies who's opening a big fabrication plant, and they're looking for 9,000 employees. Oops. Yeah, 9,000 employees, and there's a shortage of skilled workers. Now, luckily, Syracuse University is literally 8 miles down the road from these guys. And Syracuse University obviously is a renowned university for high-tech research. However, using Inspec Analytics, you can see that Syracuse does a lot more research than Micron. Micron Tech are one of the organizations in Inspec Analytics. Syracuse does a lot more. The green bar is Syracuse's research output by articles. And they're doing a huge amount more stuff in physics, a huge amount more stuff in electrical engineering. When you take a look at what Syracuse does, they're really, really very strong on gravitational wave detectors, particle physics, astronomy, AI. They're doing a lot of work in high-tech science areas. However, astronomers are not necessarily the best people to then go work in a semiconductor fabrication plant. So Syracuse significantly increased their engineering school budget, and now they're looking at what they should be doing to generate a cohort of engineering graduates who can go work at that fabrication plant down the street. So they need to work out what they're doing. So with the organization comparison, you can drill down within our subject classification hierarchy and start seeing, well, over on the left-hand side there, the blue bar, which is Micron Tech, they're publishing more articles, a lot of conference proceedings on circuit theory and circuits and components and electron devices. Syracuse is doing far more in electromagnetic fields and communications, but that's not really so relevant. That's not what Micron wants. So, drilling down another level, Micron is doing far more in semiconductor doping, in surface treatment, in lithography, in radiation effects. Syracuse is doing nothing at all in metallization and semiconductor process modeling. So if you can understand what Micron Tech is publishing research on, and you can teach your undergraduate engineers those topics or something about those topics, then you're going to be a far better academic partner. And of course, there's academic industry collaborations to be going on not besides providing employable engineers. Also within chemistry, Micron Tech doesn't care about chromatography or electrochemical analytical methods, and Syracuse is doing those. They care about the blue ones, which is electromagnetic radiation, mass spec, and electron spectroscopy. So the chemistry department can change the kind of analytical methods they're teaching their undergraduates as well, so they're more employable, so they're more useful to the big company which has just invested $100 billion in a fabrication plant down the road. Taking a look at what specific subjects, and I don't want to run over time, but the blue bar, again, is what Micron Tech is doing. They're doing DRAM chips, NAND circuits, solders. They've got 14 articles on solders. Syracuse has not done any research on solders. So again, this is one of these areas where Syracuse needs to be able to find what to do, which subjects to do research on. You can take a look at what Micron Tech is doing and click on those author lists and find there's 140 authors at Micron Tech publishing research on flash memories, or 139 on DRAM chips, and you can click that and see the names. And then go out and find them. So you can see who to collaborate with, who to approach about project, and you can see which funding bodies are funding their research on it. And so we ran several seminars for them, for their engineering faculty. These are the things you need to be doing. These are the people to collaborate with. These are potentially the people to hire. And these are the conferences to go to bone up on these particular subjects. And now they have changed what they're doing. They're now doing more research on finite element analysis, on flash memories. The light blue bar is where they've started doing significantly more research than they were. And in fact, I haven't got a slide on this, but they have now started co-authoring research with Micron Tech in the last 6 months, which they had never done before. So now they are actually doing work which is relevant to the local employer, and they're able to modify their engineering syllabus to be a more useful academic partner for corporates and get some of that CHIPS money. Finally, MIT. The world has changed over the last few years. The US government has brought in new policies. So for example, they brought in executive orders and policies to ensure that sensitive academic research is protected, that they know who's doing research on what particular topics. They're looking, there's lots of reports coming out about which universities in the US are doing research on material science or quantum cryptography with institutions that the US government may not want to. And whether you agree with this or not, this is what is happening. So research security and then funding, there is the risk, pardon me, there is the risk that if an institution, if a university in the US does not know that they are doing sensitive research on sensitive topics with specific institutions in many different countries, they could lose federal funding. And obviously that will be a blow to the organization. So the provost at MIT requested reports. Again, this is Inspec Analytics. That bar chart on the right is how many articles are they publishing with top universities in China, with Tsinghua, with Peking University, with Beihang Institute of Technology, with National University of Defense Technology, some of which are fine, some of which are questionable, and they need to know about it. And again, this is where the thesaurus comes into it, because then they can see, well, these are risky topics. Who are we collaborating with on these risky topics in Iran, in China, in North Korea, etc.? Because it's already happened, we can't stop it happening now, but we do need to be able to mitigate against it, to be able to say there's a particular reason for it. So they want to be able to generate lists of universities they're collaborating with, lists of universities that other US or European institutions are collaborating with, and then specifically on specific topics, such as here's a chart over on the right-hand side, which is deliberately too small for you to read, which is a list of Chinese universities that MIT is co-authoring research with on quantum computing, which is one of these risky areas. So you can see they have increased their research. They're scaling down a bit now, but you can see here who are they doing research with on questions that may raise questions in the Senate and may potentially lead to further investigations, lots of audits, and then potentially losing research funding. So then you can see this is what they're doing with the People's Liberation Army of China. And it's fine. Because it's astronomy. They're doing research on astronomy, on black holes. This is actually only 2 articles. There are multiple different topics there, multiple different keywords. Those 2 articles are indexed with multiple topics. But they're doing research on black holes, active galaxies, accretion disks, galactic nuclei. No one really cares about that from a national security perspective. They're also doing research on gears and grinding and a bit of material science stuff, which is a bit more questionable, but they are doing that work with the People's Liberation Army of China. And then this is what they're doing with the National University of Defense Technology, which is high-speed optical techniques, 3-5 semiconductors, quantum cryptography, quantum optics, semiconductor growth. So these are more risky topics that they do want to know about. The work's already happened. They do want to be able to know about that so they can then investigate what's happening, make sure that no one had access to the wrong kind of information. So to summarize, and I am pretty much on time, those 3 case studies, one of which was looking at global, regional, Canadian research trends for emerging technologies as a course which teaches undergraduate engineers about the real-world implications of their research and how men and women are differently affected within these different topics, and there is quite a significant change. How does this particular topic impact the world? The next one is adapting to reshoring. How can a university get some of that CHIPS funding, and how can they be a good academic partner to the company moving down the street, and how can they prepare their engineering graduates for the specific topics they need to be able to get a job at that particular fabrication plant? How do we need to change what we're working on? And then the final one is the institution has done this research. What have we done? Who have we done it with? What do we need to be able to present to auditors, to investigators, saying, why have you been doing research on that particular topic with those particular organizations? And how can we defend ourselves against that and protect our future funding? So I did have an acknowledgement slide, but it doesn't seem to be here. So thank you very much. Thanks for your time.
Hi, thanks for the talk. You showed to us thesaurus and subject headings, and I saw that there were different numbers of subjects and terms in the thesaurus. What is the difference there? Like, because the thesaurus has got 10,000 terms and the subjects were only 3K.
Sorry, I didn't hear the last number you said.
3,000.
Yes, so there's 2 different types of subject indexing we apply. One is from our list of control terms, our thesaurus terms, which are more granular, and that's the broader term, narrow terms, related terms. And there's 10,000 of those, 10,125 of those. But there's also the subject classification scheme. So one of them is saying what this article is about. And the other one is saying where does it fit in the map of science. So a subject classification scheme is the 5-level deep thing, which may say different types of materials or processes or whatever. There's a lot of similarity between the 2. One subject classification code may represent 1 or 5 or 10 thesaurus terms. But we apply both of them, and you can mine both of them within the tool.
Okay.
Does that answer your question?
Yeah. Is it open? Can we download it and inspect it?
No, it's not. No. We are a non-profit organization, but any profits you make from selling the database go back into good works for engineering and technology. Okay. But we are talking about what we can potentially do with that. It did used to be open for academic use, but when AIs came along, we realized that was going to be problematic. So,
okay.
But Inspec Analytics gives you access to it. And there is an API available for it as well.
Thank you.
You've mentioned that in the Inspec Analytics, you can find the most cited organizations on different topics. Where do you get the citation data? Do you source it from Inspec or from some outside sources?
We get it from Crossref. So it's articles cited by other articles in Inspec, but then we look up the data on Crossref.
So the citation data itself comes from Crossref?
Yes. Yeah. By the way, Inspec is one of the databases on Web of Science, and we just put in a link from Web of Science to Inspec Analytics. So any subscribers to Inspec on Web of Science will have a link through to the concept pages and the ability to search back into Web of Science. That just came up. I think he wants to ask a follow-up question. That just came out a couple of weeks ago.
No. I'm sorry, we ran out of time. So thank you so much, team.
Okay, so sorry for the slight technical delay there. So yes, now we have Dr. Álvaro Cabezas, and he's going to talk to us a little bit about bibliometrics and research, evaluation and practice. So.
Thank you. Can you hear me? Yeah? All right, thank you very much. Thank you to the conference committee, and especially to Barbara for this kind invitation. Well, it's 4 p.m., which is siesta time in my country, in Spain, so I just hope that this presentation doesn't make you too sleepy. And I will talk, my talk will focus on a problem that probably you are living in your daily work, if you work in universities especially, and it's how to navigate between the demands of your university administrators and the principles set up by COARA and by other responsible metrics initiatives. Even if your institution have not signed COARA, probably you want to adopt some of these principles. Usually, research administrators want to see the university achieve better results, publish more papers in high-impact journal, attract more international students, attract more funding, and many of these things are measured by bibliometric means. On the other hand, both COARA and other declarations, other responsible metrics declarations, emphasize the need to improve how research is evaluated and reduce the importance of bibliometric indicators. This, of course, causes tensions. These tensions between what we could call the idealism of some of these manifestos and the pragmatism, which is represented by bibliometrics methods, had extended into the literature of our field, leading to a very interesting debate among supporters of both perspectives, with many papers, reports, and opinion pieces published in the last months. The last one was last week in the London School of Economics Impact blog, where COARA representatives made some clarifications about how they understand the role of bibliometrics in research evaluation. And they understand that bibliometrics have a supporting role in complementing qualitative assessments. This was in response to a previous paper by the International Society for Scientometrics and Informatics president, which was very critical with the COARA principles. In short, I think that we can find intermediate spaces for understanding that could lead us to a fairer and more balanced approach to research evaluation. In recent years, a significant number of issues and threats have emerged in the academic field. The rise of paper mills, the multiplication of scientific frauds, unethical practices, aimed at increasing the number of publications, toxic academic environment, pressure to publish, often resulting in mental health problems. Many stakeholders have identified the evaluation system, especially those based on inappropriate metrics, as one of the main causes of these issues. Therefore, it's proposed to change these evaluation frameworks and base them on fairer and more equitable methods. However, bibliometric methods and techniques are at the same time powerful tools that allow us to combat fraud and bad practices in science, as you can see in this slide. We can identify, for example, hyper-prolific authors, those with unusual international collaborations, or those publishing in unrelated fields. Additionally, thanks to bibliometrics and large international databases that collect citation and publication data, we can identify journals engaging in fraudulent practices, such as excessive self-citation or citation rings. You can see here, for example, a screenshot of one of our favorite Swiss publishers with a lot of self-citations and also citations to other journals of the same publisher. Thus, bibliometrics is an excellent tool for improving integrity and ethics in scientific communication, of course, when used by experts. As you may know, COARA stands for the Coalition for Advancing Research Assessment, and it is a union of research and development institutions, funders, government bodies, which advocate for a reform in the way research is evaluated. As of July, we have 676 organizations that have joined COARA. Do you know how many are from UK? No? No? 20 from UK. Do you know how many are from Italy, Angelo? We have 65 from Italy. We have 49 from France. We have 33 from Germany. We have 80 from Spain. Spain, in fact, actually is the country with more institutions that have joined COARA. Probably this shows a big problem in how research is evaluated in some of these countries. These are the 4 core commitments that institutions have to comply when they join COARA. Recognize the diversity of contributions, base research assessment primarily on qualitative evaluation supported by the responsible use of quantitative indicators, abandon inappropriate use of journal and publication-based metrics in research assessments, such as H-index, journal impact factors, and journal metrics. And in 4th place, avoid the use of rankings of research organizations in research assessment. As you can see, 3 of the 4 main commitments are related to reduce the emphasis on metrics and a preference for qualitative over quantitative methods. This, we can say, aversion to metrics have raised concerns among some bibliometricians, as we will see later. And COARA's actions are also based on a set of principles, 10 principles for overarching principles and 6 assessment principles that you can see in this slide. These principles are largely in line with those from other responsible metrics manifestos. In my opinion, while main commitments may be controversial, these 10 principles are common sense, and it would be appropriate to comply with them. As you can see here, there are no principles related to metrics. In this sense, COARA can be considered the final product of several declarations and manifestos made over the past decade in various cities and by different stakeholders. Here I've highlighted some of the most important ones: San Francisco, Leiden, Helsinki, Hong Kong, etc. But there are many more. For instance, this year the Barcelona Declaration on Open Research Information was issued. Ultimately, what is being demanded is a fairer evaluation of research, nothing more, nothing less. Before we proceed, I want to make an essential distinction, and is that bibliometrics is not the same as research evaluation. While bibliometrics is a fundamental part of research assessment in most countries, research evaluation can occur without using bibliometrics. Additionally, bibliometrics can be used without an evaluative purpose. This would be the so-called descriptive bibliometrics, which aims to track the scientific activity of an institution and monitor and forecast trends, detect patterns, and even identify fraud and bad practices, as mentioned earlier. All these actions do not have any explicit evaluative purposes. So while responsible metrics manifestos focus on research evaluation and mainly at the individual level, my view is that even bibliometric work, including the more descriptive bibliometric work, should adopt a more integrative perspective and apply some of the principles of the responsible metrics, along with other best practices that are often lacking in more traditional bibliometric reports. Usually, bibliometric reports are dependent on only one databases. Sometimes are even automatic reports generated from Web of Science or Scopus, and have a narrow scope, only measure papers. And I think this is something that had to be changed. Some of these ideas were presented in this COARA paper, in this paper from 2021, in which with my colleague Torres Salinas, I proposed 10 recommendations for the preparation of bibliometric reports in institutions. These advices, these recommendations aim to go beyond the automatic reports that can be generated from bibliometric suites. Here you have the 10 recommendations. I think that the two first speak by itself, so we can go directly to the methods section. Regarding methods, the selection of indicators is never innocent. It plays an essential role in the report, and bibliometricians know that choosing one or another indicator can provide a negative or a positive view of the scientific activity of the institution. So we should be honest, not picking up indicators where our institution performs well, and use standard indicators which are validated by the scientific community. We also should take indicators that do not overlap and that allow us to offer a multidimensional view of the research carried out in our organization. For transparency, it's also recommended to describe how metrics are calculated and what's its meaning. It's also important using several data sources, as usual databases lack coverage of humanities, arts, and some social sciences discipline. This is true especially for non-Anglo-Saxon countries, where most research in these areas are published in national journals and publishers. We have a range of databases, not only Web of Science, Scope, or Dimension, but also local and regional databases, like, for example, DialNet or Redali, Coroscielo, in the Latin American area, which are really valuable resources for complementing this kind of reports. And also relating to methods, we will have to do, again, some choices, like, for example, the time frames analyzed. Here I recommend to use relatively long time frames to observe the evolution of the indicators over the period. A minimum period of 5 years of analysis is recommended. Regarding the results, an obvious recommendation is to compare results with other institutions which are in the same league than us, and also with international benchmarks. As a lecturer on bibliometrics to many Latin American professionals, I always recommend them to compare their indicators, not to compare their indicators against top universities like MIT, Imperial College, or Harvard, but to compare against national and regional benchmarks that I think it's much more useful. Regarding responsible metrics issues, it's advised to get support from experts which can provide insights in particular aspects of the report. For example, a rapid increase in citations in one specific discipline or in any other aspects that may not be revealed by the data. As stated by many responsible metrics manifestos, it's relevant to attend to the diversity of disciplines and outputs of the institutions. We should not carry out any more reports where humanities, arts, or social sciences are largely ignored. And of course, incorporating indicators related to gender equality or others related to the quality of the research process itself would be appropriate, as well as make the data open. Also, we should move away from conducting exclusively bibliometric reports. This should be complemented with other relevant activities of the institution, which give us a much broader and more accurate picture of the research activity in that institution. This information is usually not available from external sources, so it must be extracted from the internal databases of the university or from current research information systems. The better the quality of the information systems, the better the quality of the report. In this iceberg metaphor, taken from a webinar of from my University of Glasgow webinar, you can see some parameters that you can include in this kind of descriptive reports. Of course, the aim is not to create comprehensive reports of 300 or 400 pages on absolutely everything the university does, but to provide a more balanced approach and reduce the emphasis on scientific article production, which is the primary indicator typically considered in bibliometric studies. As mentioned earlier, it's essential to differentiate between bibliometrics and research evaluation. This is where we find the greatest tension between the both approaches, between the pragmatism, the bibliometrics pragmatism, and the coarse idealism. Research assessment refers to a set of procedures, techniques, and methods used to make decisions about research activities, so its purpose is always evaluative. As stated before, research evaluation can use bibliometrics or not, and techniques and criteria should be chosen according to the institution's needs and adapted to research disciplines and also to practical issues such as money, time, and benefits to institution. Research evaluation is a broad area of practice. It's not only about assessing papers, counting citations, or calculating H indexes. It also involves evaluating requests for, here you have some examples, for research mobility, conference funding, scholarships, book editions, article processing charge funding, research project, and many other things. In this screenshot, for example, you can see an application to fund an article processing charge of a paper in my institution. And of course, we don't need to use bibliometrics for all of these things, nor peer reviewers. For example, we can allocate funding for conferences based on criteria that take into account its trajectory, prestige, and quality. For example, this is the criteria that we use in my university to assess if we concede funding for congresses. As you can see here, we take it into account the number of editions of the Congress, the relevance of the society or the institution that organized the Congress, the prestige of the scientific committee, well, and other criteria. As an example, in our field, in the bibliometrics field, the International Society for Scientometrics and Informatics Conference and the Science and Technology Indicators would be two congresses, are two congresses that are highly respected and that comply with this proposed criteria. And if you work in research evaluation, whether you are a bibliometrician or not, my position is that we should design pragmatic processes that take into account the complexity of each call and also the money to be allocated. We should not consume the same resources for evaluating a conference funding, that could be maybe £1,000, than as we would for the assessment of a research project, that could be £40,000 or £50,000. While the first could be executed by skilled technical staff, the second needs to be evaluated by peers or scientific committees tailored by area or discipline. As a consequence, it's more costly and time-consuming, but it's also more specific and more appropriate. And here we have other hot discussion. Which kind of methods should we choose? Quantitative, qualitative, mixed methods. While COARA assumes the superiority of qualitative over quantitative methods, more balanced approaches like the scope framework suggest exploring both options and choosing the most suitable method for the specific assessment. I think this is a more realistic approach, as in my opinion, qualitative methods are not always better than quantitative methods. And there is not always a need to complement or support one kind of method with the other. Sometimes you can use only quantitative methods, others only qualitative methods, and in others you will need to use both approaches. In this regard, some prominent scientometricians, like the ISSI president, Giovanni Abramo, are not happy with some of the COARA commitments, and this prominent scientometrician made some bold remarks in a recent paper in Research Evaluation. He recognizes that there is no one-size-fits-all methodological approach to conducting research assessment, but states that scientometrics leads to more efficient and cost-effective solutions for evaluating research. So he introduces the idea that cost-benefit is an important parameter in research assessment. I think that many university administrators and research managers will agree with this idea. So in his view, the appropriate response to the misuse of metrics is not to revert to peer review, but to rely on professional evaluative scientometricians. And last week, COARA's steering board responded to Abramo's paper, stating that there is a place for scientometricians under the COARA framework and reinforcing the role of metrics in supporting qualitative assessment. They also state that peer review should be preferred over only scientometric methods to allocate rewards at an individual level. Well, this remains a lively discussion, one that probably will continue in the coming months or years. As the prominent bibliometrician Kevin Bojack said on Twitter, both sides probably aim for better assessments. The difference lies in how to achieve them. And here we have a good example of collaboration between peer review and metrics. And this is the process that they have designed in the University of Vienna, specifically in the Library Bibliometrics department of the University of Vienna. They conduct bibliometric analysis in cooperation with the evaluative researcher. Then they send a report to the peers and to the university administrators, so they can take, the administrators can take an informed decision about a researcher promotion. It's a good example of this that other bibliometrician, Henk Moet, called informed peer review, or the qualitative and quantitative methods approach to evaluate research. In my opinion, bibliometric techniques should, of course, only be used when appropriate and with full awareness of their caveats and limitations, but we should be open to some new approaches that can be useful for better assessing researchers. For example, narrative CVs, which are very popular here in UK, are being introduced by a number of organizations worldwide. For example, in my country, in Spain, the National Agency for Quality Assessment and Accreditation, ANECA, which is responsible for accrediting scholars for promotion in the universities, has just modified its evaluative framework. This agency, which signed COARA last year, implemented a new evaluation system that is less dependent on bibliometric indicators. Previously, an absurd number of publications in impact journals was required to achieve the highest position in the academic scale. It's more than 100 publications in some disciplines like chemistry or biomedicine, more than 100 papers, and with the majority of them in first quartile journals. This has changed, and now applicants are asked to submit a maximum of 20 research contributions, not only papers, can be books, can be papers, can be other kind of research contributions. And additionally, they must defend the importance of each of these contributions in a narrative form. They can use, of course, bibliometric criteria, but they also can justify their work using other types of evidence regarding the relevance of their work. Social relevance, local relevance, cultural relevance, for example. This framework has just been implemented, and the first results are expected in early 2025, but it has been well received in the academic community, as it also reduced the bureaucratic burden on applicants. As many agencies are doing, we should not be afraid to introduce innovations in assessment. For example, measuring not only outputs, but also the quality with which research is conducted. Some aspects that could be measured include transparency, reproducibility, methodological quality, innovation, research ethics, and other kind of impact, not only bibliometric or academic impact. It may take some effort to implement certain indicators, but it also promotes more inclusive practices in line with the best international standards, as proposed, for example, in the Hong Kong Principles for Assessing Researchers. In this regard, some examples of implementing more inclusive evaluative practices, such as those proposed by countries like Finland, are quite interesting. We must also consider that not all institutions are at the same point when it comes to implementing significant changes to their evaluation processes. The human and economic resources of each institution can vary greatly, and in some environments there may be a strong resistance to change, especially from researchers with higher levels of consolidation. That's why it's also very important to know what researchers value when they go through an evaluation process. Scholars are probably one of the most evaluated professions in the world and are constantly being measured on multiple aspects: teaching quality, scientific productivity, ability to attract external funding, knowledge transfer capabilities, societal engagement. They are also evaluated when submitting a paper to a journal or when applying for a research project. Since they are constantly evaluated, in my experience as a research evaluator, my impression is that they don't mind the specific criteria applied in a particular call as much as they care that the evaluation process is fair, based on clear criteria, transparent, fast, and simple, so it involves little bureaucracy and no complex CV formats. Therefore, in my opinion, we need to find a balance between the principles of COARA and other responsible metrics initiatives and the necessary pragmatism required in the day-to-day operations of an academic institution. Whether we have a role in producing descriptive bibliometric reports or are responsible for research evaluation, we must consider this responsible metrics perspective, but without obsessing over fully complying with them. Instead, we should choose the options that are most practical and serve the goals of our institution best. Thank you very much for your attention.
Okay, well, thank you very much. Is there any questions? Yep.
Thank you. That was really an interesting presentation. I'm wondering, are you aware of any research evaluation systems that allow people to talk about failure and what they have learnt from that?
I'm not aware. I'm not aware. About failure?
Yes.
You say?
Because, you know, if people only talk about their successes, often that can promote people from doing very safe things that they know are going to work. So if you start embracing failure as a sign of innovation, risk-taking, I'm just wondering if you've ever heard of any system looking at that.
Well, the narrative CV format that is implemented by a number of institutions permits you to explain, for example, gaps in your trajectory or why you have not published in 10 or 12 years. And I think it's a good way to address this question. And I've seen some colleagues that in his website, they put not only the funding that they have win, but also the funding that they didn't get. So it's a manner of this, no? of showing that academic career is not only about success, but only about failure.
Okay, and we have another question over here.
Thanks for the talk. Going back to the numbers, countries that subscribe to Quora, you mentioned UK is way lower than Italy and Spain. And I'm wondering why that is happening. Can it be the case that perhaps in UK the way research is evaluated, it's more on the qualitative side, in which we write impact cases for each paper we submit, compared to Italy and Spain, for example? I mean, I'm aware of the Italian system, for example, that they get evaluated by which quartile the journal they submit their paper to. So what's your intuition about, and for example, what can we do to improve the situation?
Well, when you say improve, you say...
Bring UK up in the numbers of subscription.
I don't know if it's good or bad to have many institutions signing Quora. Yes. So I wouldn't say that Spain or Italy is better because there are more institutions signing Quora. I really don't know about the system, of the research evaluation system here, but in Spain, of course, there is a very, very, very high dependency on bibliometric indicators. So it has called to this situation of pressure to publish and all of these things. But I think that it's also a political thing. In Spain, the main agencies have signed Quora, so many institutions and many research organizations have signed it later. So in my view, I don't know if it's a political reason. Maybe, for example, there are no institutions from the United States in Quora. There are no signing institutions. Why? Maybe Quora is an initiative that started in Europe and is slowly extending for other countries. I don't know. Of course, in Spain, the research evaluation is a very big problem, and probably in Italy is the same thing. But really, I don't know if it's good to have many institutions signing Quora, or if it's I don't know if it's a good or a bad signal, really.
Okay. Any other questions?
Thank you, Álvaro. Now we have here our vendors, our sponsors. What is the role of vendors in this context, in your opinion, in your knowledge?
Well, we need data. We need data. For example, some initiatives recently called for deleting the title of the journal where you have published in your CVs. I think that's not the solution. The solution is to provide more information to the evaluators so they can have better decisions. If we have more databases and more data sources to assess research, I think that's much better. If we now have OpenAlex, Overton, and many other databases that complement the picture, that give us more information to better evaluate researchers, not only researchers, to evaluate research groups, departments, institutions, whatever. I think it's good news that we have many databases to use them and to perform better assessments.
Okay, one more.
Just picking up on the question there about why some places have signed more than others. I was wondering, you had your little chart of the things over time. We started with DORA about 10, 12 years ago, and there's increasing numbers. Is there a risk of sort of declaration fatigue of institutions saying, well, when there was one of these to sign, that's great, and now there's 10, and we need to think about them all, so maybe we'll not think about any of them?
Well, I think it's difficult to adopt these principles and to implement these principles in a framework, in a evaluative framework. It's as you say, it's more than one decade from DORA, from Leiden. It's all news, but now it's getting more popular than before. So I really don't know how it's gonna be in the future. I think that some initiatives are interesting. Narrative CVs are interesting. They can have also the limitation of showing a very only a part of your research activity, no? Because research is also a failure. But well, we'll have to see how it works, and if it works well, or if we have to go back to bibliometrics or only to peer review. We will see how it works.
Okay, is that everyone? Okay, well, thank you very much. That was a brilliant talk. Oh, okay, we have one.
So there is no online question, so this is my original question this time. So as you might imagine, signing a principle or any other thing within an institution can be bureaucratically very difficult. So do you think who should be...
Why difficult?
Yeah, difficult, yes. It is bureaucratically difficult to get a principle signed by an institution. It can take, maybe years, maybe you can do that. So my question is, who should be the main responsible for signing that? I know maybe there is no single person, but you said some countries achieved that and signed COARA more. So who was the main, trigger for getting this signed?
I don't know. In my institution, for example, who is the people in charge of COARA principles and these things? You mean?
Yes. Basically, do you think should the signature request come from top or bottom to the top?
Usually comes from the top.
Top. Otherwise, it would be difficult.
At least
I
in my
guess.
institution, other institutions I know, it comes from the top, from the rectorate and these administrators.
Thanks.
Thank you very much.
Thank you.
That was a fantastic final.
Before I give the last remarks, I would like to mention that Overton, as a part of our sponsorship, offer to the LIS-Bibliometric community the possibility to apply for the micro grant as a part of this community. So have a look on their on the website. I think they have a question in the section encouraging applicants to let them know how they heard about the micro grant. This way they can spot that the list is coming from the LIS-Bibliometrics candidates. So if you are working on a project, it might be worth considering apply. This is part of the sponsorship. I hope you enjoy the conference as the same as we enjoy organizing it. As I mentioned before, we have produced a survey to gather the training needs that the community is facing. We plan to send the survey through the email and also disseminated in different platforms to get as much as responsible as possible for us to know and understand the needs. We are here, the committee is here to support the community. Please get in touch if you think ideas in which we can collaborate. Thank you all for coming virtually and in person, and have a good rest of your day. Thank you.